Good afternoon. Good afternoon, everyone, and welcome to Wichita State University's Innovation Campus. Welcome to NetApp's Defiance Room. How many people have been here in the NetApp building before in this space? Great, a lot of you. We always thank NetApp for so graciously providing this space for us to have opportunities to come together. It's really, really nice. How many people found parking and they were surprised? Yeah, okay, good. That's part of why this is a great space. So, welcome. We have a lot of people here from across the nation and across the globe. They're very excited for us for all of what's happening in Wichita and in Kansas, for all the economic opportunity that is before us, and specifically about interconnection and AI. And that's what this summit is about. So I am very, very excited to bring this group of folks to you. Everything that we're doing today is being recorded by our wonderful Wichita State University Media Resources group. So thank you. It will all be recorded and available to you. It might take us a minute to get it all edited and available, but if any of this is meaningful to you and you want to share it, it will be available for you to share. As well as all of the speakers that are here because they want to transfer their knowledge to our region. Okay? They came here not as experts to tell us what to do, but as visionaries to help us see what they've done before in other places and to learn with us how we can build on their knowledge and what's before us in tech and what we could do here, maybe even differently. They're very excited about that. So all of the speakers are also going to be, available to you as subject matter experts if you need follow up. If you go back to your organizations, your groups, and you're like, yeah, I kind of remember that, but now I've lost the whole meaning of it. Don't worry, because that's the whole purpose of coming here together is to learn from each other, to do some knowledge transfer, and to build something maybe even bigger and better than what is in other places. So I really welcome everybody, and thank you for taking time this afternoon to do that. With that, I would like to take just a moment of silence to reflect on September 11th, what this day means, the lives that were lost, the families that were changed forever. So just take one moment with me and think about that. Now I'm going to ask you to act like it's September 12th, okay? And embrace the grace and empathy and connectiveness and human-centered kindness that we all put together. So in the world right now, there's lots of other things going on, and I would just say that this is an interconnection summit. We're all people. We're all here to learn and work together and do something, better together. So please think that through in your afternoon and as you leave here. And with that, I would like to introduce a video from President Muma. Wichita State University's president could not be here. There is a DC fly-in happening right now at the airport, and several of our executive team needed to be there, and it was previously scheduled. So he is very excited that you're all here and sorry that he's missing it. So we have a short video from him welcoming you to our campus.
Welcome to Wichita State University. I'm President Rick Muma. We're delighted to have you on our campus. This is innovation fuels opportunity, where ideas turn into action and where the future takes shape. I hope you enjoy your time on campus and experience the energy that makes Wichita State such a vital part of our community. Go Shockers!
Thank you. And now I want to kick it off by introducing Tom Furry. the chairman and CEO of Connected Nation, the organization that is bringing interconnection to our state, and a dear friend of mine. So, Tom, please join us and take it away.
Well, thank you, Tanya. I'm not overstating when I say I think all of us are here in large part because of you and your vision and your innovative spirit. Um, you saw the possibilities for this project long before anyone else did, and so we are grateful for that and grateful to have your continued support and engagement as we go forward. I also want to thank you for your leadership and your entrepreneur spirit. Those are going to be continued traits that we'll draw against as we embark on this exciting journey together. As Sonia said, I'm Tom Ferree. I've been with Connected Nation for, I guess, 18 years now. We're a national nonprofit who has dedicated our time, talent, and treasures for the last quarter of a century to addressing the digital divide. Now, this work has taken us from Washington, D.C. to countless state houses and community centers all across the country. Now, we are most excited, perhaps, about this new expression of our mission. Joining in league now with our esteemed partner, Hunter Newby, we match our 24 years of experience in digital divide issues with his 24 years now in experience, well, more than 24 years of experience in digital infrastructure and network interconnection. Over the course of humanity, there have been a few general purpose technologies that have revolutionized our human existence and our standard of life. Comes to mind farming, the factory system, printing press, and of course the internet. Artificial intelligence represents the apex of these general purpose technologies. We are at the precipice of a great democratization of power and risk because of it. And yet the vast prosperity, and then on the other side, the risk containment that AI promises relies heavily on the mass diffusion and its accessibility. To influence this coming wave, like in life and in business, there's no substitute for being in the room. And the problem is, and that's the gating factor in how quickly and to the extent that all Americans will participate in this coming wave, is that there aren't enough rooms to support this mass diffusion. We are going to change that, and we are starting this innovative journey right here in America's heartland on the campus of Wichita State University. Now, clearly stated, I think the objectives today, this is, as I was telling someone, a horse of a different color. This is not your typical AI conference. We're not necessarily going to hit the technology head on. We're going to focus on the things that enable that technology. And so we hope that you'll connect with folks, network with folks, and leave here a little bit more informed about some of the things that perhaps you took for granted and understand why this investment and this time here at Wichita State is so critical to being an archetype for how the rest of the nation will become competitive in our race for AI dominance. Now, on the note of innovation, it is my esteemed pleasure to bring up a special guest, someone who's tasked with creating that agile and forward-looking environment where innovators and innovative companies can flourish across the state. He's got the experience and the pedigree to make it happen. He holds a master's degree in economic development and innovation. It's my great pleasure to introduce to you today the Chief Innovation and Strategy Officer for the Department of Commerce at Kansas, Mr. Romain Redmond.
Good afternoon, everyone. It's no longer morning anymore, but before I start, I wanted to just recognize and thank Tanya for taking that moment to recognize the significance that is September 11th. 24 years ago, the world and this nation was, forced to look at the environment in which we live and think about how to secure that going forward. And I think even today's action is a reinforcement that we learned from that experience, and we're resolute in our mission to continue going forward with strength, with vision, and with pride in what we hold so dear. So thank you, Tanya. And of course, I want to thank the Connected Nation team, of course, Chairman Ferree, the vision that you have and bringing that right here to Kansas, Wichita. I know we're at the core, and at the core, many beautiful things happen. So thank you for helping us to continue in that sterling mission of keeping brilliant things and wonderful things happening in this great state. But for me, though, it's an absolute pleasure to stand here in front of you today to talk about something that is literally the life I breathe, the breath I breathe on a daily basis. Innovation, AI being the next new bright, shiny thing. But at the core of that is how can we really harness the power of AI to deliver the kind of prosperity that we want to see as a state and as a nation. And for that, I am very proud to hold this position. But Kansas has always understood the importance of connection. We've done it with our railroads, we've done it with our highways, we've done it with our grids. And today, broadband and interconnection will build our future. And that is why we're here at the AI Summit 2025, right here on the campuses of Wichita State University. But Kansas is also at an inflection point because you see, for decades, infrastructure projects like our highway systems that I mentioned have defined how communities live, work, and thrive. Now, broadband, and specifically the establishment of Kansas's very first internet exchange point at Wichita State University, is our generation's transformative leap forward. And folks, I'm very excited about that because I love the leap and I love to see brilliant things happen here in our great state. But this really came when we heard the vision that Connected Nation had, and we said we're not just gonna say yes, it's a bright and beautiful vision, but we're also going to put some dollars behind it because we know that to achieve anything, we have to put together all the resources that needs to make it happen. And we made a bold investment of $5 million to have this IXP built. And I just got an update from the team to say that by next spring or so, it should be online. So I think the team deserves a round of applause for that. Yes. But the IXP is not just about faster speeds, it's about unleashing innovation, strengthening our state's economic competitiveness, and of course, expanding digital opportunities for Kansans no matter their zip code. And that's a hard mission for the Kansas Department of Commerce. Already, we're seeing where our infrastructure investments in our AI and connected networks are paying off with that 83.5 million investment done alone through the HARPA funds that we received as a state. We are impacting over 25,000 homes and businesses right here in the state. And research has shown us that these kind of investments have the potential to unleash over 200% higher growth, business growth that is, in communities, delivering about 20% higher incomes, and of course, stronger GDP growth. Isn't that something wonderful? Isn't that what we all want to see in our state? And my friends, that is the winning formula. That is the winning formula that's going to have Kansas not just competing with the best of them, but outshining the best of them, having infrastructure like this in place. But I want you to also think of this in practice and what it means in practice. In our education sectors, rural students now have access to the same digital learning opportunities as our major cities. Healthcare, through telemedicine, reduces hours that the patients have to travel to seek specialist care. And of course, in agriculture, which is the lifeblood of this state, precision technologies are helping Kansan farmers to increase yields and sustainability, not just feeding local, but feeding national populations. And of course, for our small businesses, internet and interconnectivity is the great equalizer. When we talk about unleashing e-commerce, and a small business that is set up somewhere in Cheyenne County has access to the same market size that the business in Johnson County have access to, that is how we win as a state. But let me also give you another tangible example because this was a very exciting one for me, and I love that it happened right here in the state. But a couple weeks ago, we had our very first FAA certified drone for commercial operations, flew 30 miles from Seneca to Onega to deliver medical supplies, a totally unmanned system. And that partnership, my friends, was brought to us by Kelly Hills and their unmanned systems and their vision, K-State Salina, the Kansas Department of Transportation, Hyman Brothers, and Pike Aircraft. Now, collaboration is also the other underpinning thing that is really going to make us succeed. We have to be able to collaborate and collaborate well. Look at the strengths that we have, the visions that we have, and ask ourselves, how can we leverage the strengths and the vision that we have to create something that is going to put us at the top of the pile? That is how we win, my friends. And then again, the other thing about this is that it also increases opportunities at the personal level. Think about the person who always wanted to do something more than what they've, been brought up seeing. Think about the person who wants to tap into the magnitude that is our internet and the World Wide Web to connect, to learn, one, to build, two, and to innovate, three. And I'm glad to know that so many of our partners right here in this great state is helping our entrepreneurs and our innovators to think beyond the four walls in which they exist. Right here at WSU, we know the transformation that our university or community partners are coming together to birth. Now think about how can we make someone who is all the way down here in Wichita connect to a global market that is all the way far east, far south, far north, or even to just expand the markets across this great nation. That is how we look at what makes us do things well and leverage it so that we can bring about prosperity for all of us. And my friends, as I close out today, I want us to leave you rather with a thought that for Kansas to lead, we must recognize that broadband and interconnection are not extras, but they are essential infrastructure, fueling transformation of our existing industries, and of course, birthing new ones. So the next appeal is with AI and all the fantastic tools coming on board, think about how can we solve the next problem. Think about how can we bring about transformative solutions that are going to change the way in which we live, work, do business, and create prosperity for all of us. Friends, as I said, it has been a wonderful pleasure joining you here today. I enjoy the opportunities like this to connect and to learn and to see all the beautiful things that are going on. The next task is just to go out and do great things. The state needs you, the state appreciates you, and the state is ready to support you on that journey. Thank you, friends.
I hear it's a good chocolate here at Towns. Maybe you can share with friends. All right. All right. Well, thank you, Romaine. All right, now, before we get started, uh, I'm duty bound to give you a few housekeeping items here. I want to make sure I get this right. So, first, I told you we're going to do a little bit of a different approach on the summit. We want you to hopefully be inspired and come up with great ideas and some questions. We're gonna have a form for that at the end. So jot those down, and when you get inspired, write it down. Don't wait to the end. We want to make sure we harvest all those great thoughts as they come to you. So write that down. Hunter will take us through a Q&A session at the end. There are drinks and light refreshments provided. I want to make sure you know that, and of course the facilities are down to the left as you exit the conference room here. Also, there will be, let's see, we've got a special giveaway tonight. You've got some tickets in the back of your lanyards here. Don't lose those. I have no idea what we're giving away, but it promises if Jessica was involved in it, it promises to be a very good gift. So we'll do that. Also, this event wouldn't have taken place without the support of a lot of folks. I want to recognize that. The Digital Transformation Hub, by the way, what a great looking room. Should have said it at the top. Yeah. And the screens aren't bad either. I was talking about you guys. This is the intellectual and creativity that we need as we start this new journey together. In the many ways, we're going to be charting this course, not just for Wichitans and Kansans, but for the rest of the country. So consider yourselves enlisted. I want to thank our platinum sponsor, Stevens Fiber Group, for making that possible today. Thank you. If you're from Stevens, let's stand up so we can properly thank you, or raise your hand there. Let's do that. Thank you. Also want to recognize our gold sponsor, Moonshot Energy. There's Moonshot Reminder. Thank you. And our gold sponsor, that is our gold sponsor. Thank you, Brian. Now, before we get started here on the next presenter, I want to start by telling you this next presenter, he's a pioneer in the creation of innovative mission-critical facilities and multi-tenant technology centers. He's also the founder of multiple companies, including Telesource, Intermetro Fiber, and Fiber Media. He's with us today representing his role as the founder and CEO of IM Data Centers. He's our construction partner here for the facility at Wichita State, and he's a great friend. Mr. Mike Warren.
No, I got it. Thanks. Hello, everyone. I'm at the end of a week-long business trip, and sometimes there's only so much that caffeine and carbohydrates can take care of. So that's what you're dealing with here. And so I've worked with Hunter a long time. Hunter and I have both been pioneers in the creation of multi-tenant data centers, carrier hotels, and such. And our role with this project, this really interesting and cool project, is that we are advanced manufacturing and deploying the actual facility. So this facility will be built in our factory in Fort Lauderdale, and it'll be shipped out as 3 modules, about 50 feet long, 12 foot wide, and 12 foot high, and deployed in a matter of days, on the site that we will also prepare for the deployment. And so that's my connection here, but it's been, I'll save it till the end, but it's been really interesting being here in Wichita and having the Wichita experience related to the innovation and technology that's going on here. And so we have 2 lines of business. These are just some snapshots, but I came out of the construction business, and we built literally millions of square feet of data centers over a period of 25, 30 years. We've developed a number of facilities, built metro area fiber loop systems, and so currently what we're doing is that we own and operate a small portfolio of data centers, and we manufacture modular data centers, modular mission critical facilities, such as this internet exchange point that'll be going in Wichita. And oh golly, I mean, we've built over 1,000 projects, over this 30-year period. I'm kind of dating myself here, but at any rate, we leaned heavily into technology back in the end of the 90s when they deregulated telecommunications. And after building every Tom, Dick, and Harry kind of project under the sun, we liked the niche market. We liked becoming subject matter experts in the field, and we like the cookie cutter nature of what it is that we now build, and how you can modularize it. And advanced manufacturing. So those are some shots of our factory in Fort Lauderdale. So we manufacture fully integrated enterprise class data centers with a specialization in high performance computing. The market has changed dramatically since the advent of the ChatGPT. Machine learning, robotics, HPC, high performance computing has been around for a while, but it's just catapulted into the forefront. Largely on the heels of the explosion of ChatGPT. But we've been at this for a while. For example, we have a facility in Pittsburgh, and we got out in front early, and we conceptualized it a half a dozen years ago. And we built it and deployed it fairly recently. And when we did it, everything in the data space, usually with regard to facilities, is counted in terms of megawatts or kilowatts per rack. It's all about power consumption. It used to be square footage, and now it's how many kW per rack, are you burning? And so we conceptualized this facility. We built it at 35 kW per rack, and everybody that I knew said, "Rourke, what are you thinking? Who needs 35 kW per rack?" And right now in our Miami data center, AMD's brand new chips that are not being deployed anywhere else in the world at this moment, the 355s. These racks are 120 kW per rack, and it's all a combination of direct-to-chip liquid cooling and rear-door heat exchange technology. So what's happened with the form factor of the data center, this radical innovation, is that Popular wisdom used to be that you needed these huge facilities with 18, 20-foot clear height ceilings. And because you needed this much volume to move the air that you needed to cool with. And what's happening is that much volume for air has been reduced to water pipes this big that are going, the water is being put inside the servers and circulated and extracting the heat from the servers themselves. So what happened was that sort of pushed, we saw that coming as well. It sort of pushed the whole form factor of the modern data center into the arms of exactly what it is that we create. So at the factory, we manufacture these volumetrically. Interestingly, we can produce data centers. We're sort of the real true picks and shovels of the generative AI and solving the digital divide. We're the picks and shovels of that initiative because we provide the facilities that this occurs in. Whatever happens with server technology, where they're talking about 1 megawatt per rack now, like ridiculously dense. But whatever that is, whatever that's going to be, it needs to be within a facility that has a fully integrated systems, i.e., security, access control, CCTV, data center infrastructure management, advanced fire suppression systems, obviously advanced power and cooling systems, all of the resiliency and redundancy that you need to have a true mission critical facility, which, by the way, is what Connected Nation and Hunter Newby are putting here in Wichita. So it's actually a very sophisticated facility. There's a high level of remote controllability and monitoring inherent in the entire building. The thing is talking always and sort of telling you if it's got any ills and what to do about it. But by building modularly, we're able to build and deploy facilities in about half to 2/3 of the time of traditional construction. One thing is that we can simultaneously do the site improvements with the manufacturing. And so there's a lot of time saving there, but also we're building inside of a factory. We're not subject to the whims of, the local subcontracting environment or, the ability of subcontractors to produce highly technical work. So we have a factory setting where we do the same thing over and over and over. And we're able to do this at about 80% of the cost of bricks and mortar buildings, which is, I find, kind of fascinating that we could give potentially a higher quality facility that's custom made for high performance computing and internet exchange applications at a lower price than traditional construction. So this is a sample facility. This is in Pittsburgh. We own and operate this facility. It's 3 megawatts of IT load. And the thing about building modularly, you think modules, you think of, these, single modules, repeated or small sort of regen huts or what you'll see at a cell tower. So this is a 6,000 square foot building. The center photograph is what it looks inside on the high performance compute side. And it's kind of a little bit spaceship looking when you get in there. It's more like aircraft construction than it is, traditional construction. And the photograph on the right, it was taken exactly 7 days after sitting the first module. And at this point, we've already put another tapered insulation roof with a TPO welded roof system on top of it. So that's how quickly these things will deploy. I know that Connected Nation has put a time-lapse camera over on the stadium across the street. So it'll be kind of neat to see all of a sudden the construction process go on and then pouring the slab, and all of a sudden the building will go and go up. So we're doing these things at scale. Like 2 days ago, I was in Fairmont, West Virginia, where we're building this massive supercompute data center for the National Weather Service, NOAA. And we're also building for Rutgers University, their supercompute data center, and a host of others. So people are really catching on that they need these types of facilities. And what did I just do? So these things scale nicely. Oh golly. Most of what we're doing for people now is north of 100 kW per rack. And that's really where the market is going. So we also acquire and reposition data centers. This is in Miami. Um, the photographs second from the left are photographs of 120 kW racks that are residing for a customer in this particular facility. So that's kind of a sprawling 100,000 square foot facility. And that's another thing that we do and that we own and operate and, for our customers. So this is a really cool project, and I'm finding that Wichita is a really cool place. So Wichita has been shortlisted for our next manufacturing facility, and we're looking at a 100,000 square foot plus facility in Wichita as a potential location to be able to open up another manufacturing plant. So we hope to do a lot more business here. And I grew up in Colorado, just to the left of here. So, and I live in Miami Beach, which is exactly like a replicant of Colorado, obviously. So every time I get off the plane in a place like Kansas or Colorado, I breathe the air and it feels like I'm home. So, yeah, I really hope we do something here. And I feel very fortunate that Connected Nation and Hunter has selected our firm to do this very prestigious and interesting project. And thank you all for coming.
You gotta watch Mike. You gotta watch Big Mike. Rob you blind. All right, thank you, Mike. That's an important piece. Now, while he has the versatility in this construction of these multi-tenant technology centers, he mentioned power, the power consumptions and the power profiles. That's a point. I want you to put a pin in it. Hunter and others will come back and to make the distinction between data centers and what we're building here. That'll be an important learning point for you today. I'll let the experts get that treatment for you, though. All right. Well, our next speaker. This individual brings new dimension to the term, taking it to the streets. As the founder and CEO of Tordex Technologies, James Young pioneered the nation's first large-scale carrier-neutral meet-me street underground conduit network, and of all places, Boston, Massachusetts. If you can do it in Boston, no offense to the New Yorkers, you can do it anywhere. This led to the digital ecosystem that empowers network operators and fosters market competition with no monthly recurring cross-connect fees. Put a pin in that one, too. That'll be another one that our esteemed colleague Hunter will litigate later today. He also founded Mass IX. That's the largest carrier and data center neutral internet exchange in New England. And no offense, folks, I'd have to say he wins the prize for the best photo from the in the field category of our speakers today. Ladies and gentlemen, Mr. James Young.
Well, thank you so much, Tom. It's a real pleasure for me to be here today, so thank you, everyone. So I'm here to we're going to talk about building physical infrastructure for connectivity in the era of AI. Just as a quick intro of who we are, I mean, Tom did a fantastic job, thank you. So we started, sorry, is there a way to whiten the background there, or is that?
We put it into their colors.
Okay, yep, no worries. Yeah, I forgot I said that. All right, so so who we are is we're network engineers, we're network nerds, and we love the internet, and we love it so much that in 2012 we decided to start our own ISP. Because no offense to existing carriers who you'll see some of our lovely partners there, we love them all, but quite frankly they kind of sucked. So we ended up starting our own, and we're a B2B provider. We also do tons of dark fiber between data centers, the usual, the data center ecosystem. So we're very popular amongst what's called a co-location customers. So co-location customers are enterprises that would take lease space in data centers to house their servers, their GPUs, what have you. Next. And then we've become New England's peering central. So just a quick recap on what peering is for some of you that may not have heard it before. So, peering essentially is the exchange of data between different internet networks. And the more uniquely peer you are, so it's interconnections, right? The more uniquely peer you are, the more shortcuts there are in your network, what we call routing tables. So that's like the map that your devices have to push the traffic. So we exchange in our city, where I come from, in Boston, when customers are using their internet bandwidth from us on our network, we exchange over 90% of all the New England traffic locally in Boston. We don't relay it through New York. When we started Tordex in 2012, it was the opposite. The 90% of all traffic, street to street, or if you have a colleague in the business next door, it's all going through New York or Chicago. It was pretty horrible. And we also started MassIX. So why did we start MassIX? So MassIX is an internet exchange that's a switch, or what we call switch fabric. As we've run our, built our network, provide connectivity services, our customers are very happy. That's great, but we can always talk about how great we are, but that's just sales pitch. So what we wanted to do is, how can we make more network? How can we make this performance available and open to as many networks as possible? So that resulted in us starting the MassIX, and to really enable our partners and our friends to also be able to interconnect directly in Boston without any fear of dealing with all these performance problems and things like that. So where do we go from there? We didn't stop there, because so far everything that we did was just network guys doing configuring routers, switches, optical, all the fun stuff. But then as we continue to expand our business, we realized that all of this is all just, at the end of that, all this technology relies on one thing: it's physical infrastructure. If you don't have physical infrastructure, can't really do anything. So what we did is, in Massachusetts, we built the nation's first underground interconnection utility. So instead of people bringing their fiber to a specific address or location of building, and then getting charged to connect between each other, we've created what's called the underground Meet Me Street, where instead of meeting only the buildings, you can now do so right out in this street. So the result is, so a lot of times when we talk about interconnections in the internet, we generally talk about what's called network gravity. So as the more and more carriers, more participants come in, this marketplace, this ecosystem of different actors, if you will, that are exchanging traffic together, that it's kind of like the innovation campus here. It keeps drawing more people in. So that so far in the internet used to be what we used to call landlord-controlled infrastructure. So when you want to build a regional, network gravity of interconnections, we always had the prevailing ideas that we always had to do in the buildings. And then what happened was, over time, we call carrier hotels. These carrier hotel guys, they realized that, there's so much economic activity, let's tax them. And that became the form of what's called the recurring cross-connect fee. So in Boston, we've gotten to a point where the recurring cross-connect fee costs more than the connectivity itself. So it really started inhibiting a lot of the high bandwidth needs of our customers and the industry partners. So we decided, well, let's do this. Let's even the playing field. How about we allow other new data centers to come in and compete? And the way we did that is take that Meet Me business, put it outside in the public streets, and all of a sudden, it just flipped the whole game. So, this is what resulted today, and it's pretty funny, because usually when you order telecom circuits, you call the carrier and say, hey, I need a telecom circuit from my office address here to a carrier hotel, like 1102 Grand in Kansas City. You need what they call AZ locations, the either ends of the circuit. And what ended up happening in Boston is, a lot of these carriers are all getting confused. They're getting all these requests to deliver services out on the street, and they're like, what's the address? So it's pretty wild seeing that in action with our customers, for sure. So the internet, as just to briefly touch on, as we all know, runs on physical infrastructure. And I think many of you will be surprised. Even a lot of people in our industry, in the data center space, IT space, even many of them have really no clue about this. Now, why is that? So normally when you look at a carrier hotel or data center development, half the time, these guys focus a lot on what costs them a lot of money and engineering. That's power, cooling, those are very costly items. But then they also, connectivity, my phone works, it's in the cloud. So, and they completely neglect and forget about the fiber, and then after the building's built, it's all nice and shiny, they figure out, well, why is there no bandwidth around here? So it happens so many times. But here in Wichita, that's not what we're gonna do. So we're talking about AI-ready networking. When it comes to AI-ready networking, dark fiber is the currency of everything. And I'll tell you why dark fiber is so important. So just a quick recap. When you want to have a private line, like from say, like here we are in WSU, from this building to say Shocker Studios, you call a carrier and say, I need 10 gig line or 1 gig line or what have you. With AI, the connectivity needs are so much that a single carrier cannot possibly provide you that connectivity service at the rate that's economical for you. So what dark fiber does is if I'm a carrier, instead of me selling you a 10 gig line or 100 gig line, which of different unit speed, I'm essentially restricting your capacity by charging for how fast the line is. Instead of that, I'm giving you a pair of unlaid fibers that were put in the ground, but nobody touched it. It's just sitting there in the ground. So now suddenly the customer is now the carrier. So if you want to do 100 gig, 400 gig, or 1.6T, whatever you want, you don't have to call the carrier. That's between you and your network guys. So, but with dark fiber, what dark fiber needs is physical infrastructure. It's real estate. Whether it's even if it's a public street, in this space, wires have to be hung on poles or they have to be in conduits. And that brings us to this. So this is a typical telecom manhole, and it's actually, don't laugh, it's actually one of the nicer ones. I've been to about 100 ones. This is actually one of my favorite ones that actually have the least problems working in. But manholes are very critical. So when we look at, a lot of people, when people talk about connectivity, broadband deployments, we always talk about challenges with pole attachments, but very rarely do we talk about manholes. And the reason is because, a lot of the manhole infrastructure is usually done in what we call shared use or joint trench environments. And what that means is, when you're deploying broadband on a horizontal scale, you got to hit as many homes as possible. Aerial poles and what you deal with poles is going to be the majority of your expense and where you're going to be spending time in. However, when you're building vertical infrastructures, like what we're doing to the carrier hotel, interconnection hubs, the IXP of the world, you need density. And the only way you're going to do that securely and scale is underground. So then all of a sudden, the manholes start looking like this, and it turns into a complete disaster. And the unfortunate thing is, as you could imagine, infrastructure congestion makes everything very expensive. Because you look at this manhole right now, so there's someone's what we call splice cases, a box through one. That's a network carrying critical traffic for FAA and everybody in Boston. Yeah, just think about that. So you got all that going on. And when the next guy wants to come out, new dark fiber provider wants to come in and say, hey, I want to compete, I want to provide fiber for half the price as everyone else. And then they find out I can't pull my fiber, I can't even get to the conduit. It's a complete mess. So then this new provider does is they call the carrier, the existing carrier that installed that manhole, who owns and is responsible for managing the manhole. Hey, I can't pull my cable, like what are we gonna do? And the first reaction the carrier does is like, oh gee, sounds like a you problem, right? And then they start thinking amongst themselves, why are our manholes so dirty? And then at some point they're like, yeah, we probably need to clean this up because this is becoming a problem. But then the other guy in the room says, oh, wait, hold on, wait a minute. This is actually a feature, not a bug. Our manholes are blocking competitions. So I will tell you right now, this is not what we're putting in Wichita. We're not gonna do it here in Wichita. This is a city of innovation and engineering, and we don't do that over here. So I'm gonna show you what is coming to Wichita. This is what's coming to Wichita. It is state-of-the-art, organized, and digitally managed and visible infrastructure. So this is not AI generated. This is an actual manhole in the streets of Boston. And it's got a floor. It's like a basement in a building. It's like literally from the street, it looks like a sewer manhole. You're like, oh yeah, it's just typical. You open it up, everyone's like, oh my God, what the hell is that down there? So when we're talking about AI-ready dark fiber and scaling that up, what we need to really discuss is we have to guarantee access. We have to be neutral, and we have to guarantee access to as many players as possible. A manhole system like this is more than just tunnels and tubes underground. It is an economic engine. So IXP facilities like this, infrastructure, are frequently accessed by crews working for many, many different carriers. So multi-tenancy and neutral access are the critical guiding principles anytime we're designing systems like this, and the system that we'll be designing here for the CNIXP that's going in Wichita today. And as discussed before, cable clutter and network congestion is, that's the number one, one of the biggest cost drivers of deploying new fiber in shared infrastructures like that. And finally, when you do want to clean this up, the manholes that get put, these large shared manholes, they constantly fill with groundwater. I mean, it's underground, it's below the water table. And it's also got the road grease, the traffic oil, you got all this mud and muck coming in. By the time you're done, about 3 months after it's been, it looks nice for like a couple of weeks, and then after that, and start cables going in, everyone's like, oh my God, this is disgusting, I just want to get out of here. So then what you end up is, every manhole essentially turns into an unmanaged garbage dump where nobody can manage it anymore. So in order to have a scalable infrastructure that is manageable, you have to start with, it has to be completely watertight. You have to hermetically seal it. You have to treat it like it's a building. And we'll go to the next one. And in addition to that, clean infrastructure, as we could all imagine, is a safe infrastructure. Our philosophy in operating our manhole system and the way we're going to partner with the folks here at Wichita to bring today is safety, operational reliability, and digitalization. So digitalized register and maintenance log are very critical. So any work that's happening in the manholes, anytime a conduit gets open, there's a digital permit that tracks that conduit. And when the conduit is closed, that is also tracked digitally in the system for follow-on inspections to make sure the water doesn't come in and things like that. And then we're also going to be using Vision AI. Think about that. There's concrete walls, pipes, and wires, and there's AIs coming into that. So we're going to be using Vision AI to actually conduct field inspection and permit to work audits. So what that allows our, in Boston, what that allows our crews to do, and what that's going to allow the crews here in Wichita to do, is instead of all this stuff going to the back office and someone just, eating snacks in his office that's not doing any work, they're going to start off with, take a picture with your mobile phone, you upload it, and the system thinks, and it gives you an initial score, and then it reports that to the reports back to our back office for the final approval. And lastly, on this point, maintainable infrastructure is very key for safety as well. At the end of the day, these manholes may look nice, and a lot of people say, oh, I can eat off the floor, I can sleep in there. But no, these are dangerous infrastructure. These are confined space, legitimately. So it's very important that we maintain this infrastructure in a very manageable and clean fashion for safety as well. So the most important is we're going to completely eliminate free-for-all activity. Everything that happens in these manholes here in CNI-XP are going to be tracked digitally. So there's no, when the carriers come in to put their cables in, there's no oh, let me just put the cable there. No, we're not going to allow that anymore. Every cable that goes in before the cable gets run will be visualized in 3ds Max and AutoCAD, where it has to be pre-designed in advance. So you don't just get to hang the cable in whatever rack that you find. You have to run it accordingly to the plan. And the other thing is disorganized activity in the manholes is strictly prohibited and also enforced. So going back to that Vision AI and the permit to work system, so when we have approved contractors in the manholes, when they fail the quality standards, then they get a warning. And when they fail again, they get a warning again. And the third time, they're out. They cannot work in the system anymore until they take a field training program to, essentially certify to us that they're not going to do that again. And so this is an example of a splice case. So before in that disastrous mud hole that you saw earlier, quite the difference. It's every tenant, every carrier coming in here, it's like just inside a building, they get a spot. This particular carrier is only allowed to occupy that spot. It's mounted, it's racked, it's always accessible. And the conduits that are coming to wall are completely sealed up. There's no water ingress, no gas ingress. So these are always sealed, and you can see these QR codes that are also used to digitally track the progress and any kind of work that's happening on these conduits. And anytime crews are in the manholes, there are signage that are guiding them not only for safety, but also for quick reference. They can put up the as-built drawing and inventory of conduits just by taking a picture with their mobile phone. Cable slacks are pretty, difficult to work with always. So the slacks, coils, they have to be mounted in their designated spots, and we try to organize them by the band radius of the cable. And as you can see, every cable that's running through the manholes is digitally designed, tracked. Every cable here has a digital ID that's in the back office system. We don't, there is, a cable that is undocumented and run without a permit is absolutely not permitted. So how are we going to build all of this? So we're going to be leveraging precast construction. Precast is very important because what you're doing is you're digging this confined space, if you will. You don't have a lot of working space. By going precast, it allows us to design the whole, to visualize the whole thing in 3D, give that to the precaster, and then they come up with a shop drawing. It allows us to create a completely, precision engineered piece of infrastructure. So right here, as an example, this particular slab is a roof slab that will support traffic. So in this particular port, our engineers specified double layering of the rebars without getting too technical, but the spacing, all that is very important. This, by partnering with Precaster, our engineers get to fully verify all of the quality assurance and the design specs before the concrete goes in. This right here is a wall where the conduits come in. So one thing that we never allow contractors to drill holes or make a cut in the wall. That's how water gets in. Every hole, they have to use a pre-provided holes that are already manufactured into the manhole. The rebars between the conduits are also very important. And then what it looks right now, this is before the concrete poured, and then what happened in the after shot is this is how it looks after, smooth, clean, white concrete. So how do we install this? Obviously, you first dig a very large hole, just like and you put some gravel batting, and then you bring out the boom cranes, and I love those cranes. So it's like Lego block. You lift it up and you just drop in the hole. It's real easy, quick, safe, right? So here's another one going in there. That's another one. That's a trench box. That's you can see the boom train. The boom crane, the spreader. It's after it was put in, and then, there's another one, and then finally. And this is how it looks after it was just put in. You can see the cable racks, the sump grade, the cantilever arms for managing cables, all that good stuff, and the signage that are being put in before. And this is another manhole, so it's a larger one. That's what we call meet me hole, where the splice cases go. This is literally the day they was put in, and you can see the conduits, the pipes haven't even arrived yet. The following day, the crews brought in the conduit. So this immediately after it was put in. And this is a finished product. It's clean, organized, how it looks from the entry point. There's no garbage or any of that allowed down there. And there's, another picture of the conduits coming in. So if you ever wonder how internet looks like or how it should look like, you're looking at that right now. And, and I gotta say, I am so proud to be here and to partner with Wichitans on this project, and I will tell you why. As I discussed, I may have touched on this briefly, IXP infrastructure is not just manholes, conduits, and fibers. It's economic engine. Now, when we're in fiber business, and a lot of people, everyone talks about how large of a fiber are you, how much fiber strands are you putting in? For us, we don't care about fiber strands at all, and I'll tell you why. That's an old, antiquated way of thinking. When we're talking about IXP, all we care about is how many cables can the infrastructure support. We care about cable count, not fiber count. And the reason for that is every cable is a tenant. It's a carrier, it's a business, it's a department at WSU. Every cable has an owner that represents endless economic possibilities. And that is what we're trying to empower everyone. We want all of our customers to come in and say, you don't have to spend, hundreds of thousands of dollars doing expensive dig, go through all the permits. Dig once. We put a big system at once, make it accessible, make it neutrally administered, make it clean, and the customers come in, and all they gotta do is they just gotta, put in your own cable. That's all you gotta do. So we're going from what we've created. What we're going from is we're going from the old landlord-controlled infrastructure, the carrier hotels that are charging expensive fees, and with CN IXP. We're now moving to the era of operator-empowered infrastructure. And that is how we're gonna scale for AI here in Wichita. And this is gonna be the first greenfield deployment after what we've done in Boston. All these beautiful pictures that we've built in Boston are really, it's really a reaction to all the chaos that's going on there. So just think of it as more of an upgrade. But here in Wichita, it's gonna be greenfield. And we're very excited to be partnering with all of you. And not only am I excited to work with all of you, I'm also excited to learn a lot from you guys as well. So, and that's the end of the presentation.
Thank you, James. Wow. You guys getting your questions together? Curtis, you getting your questions together? All right, Jade? A lot of them. There you go. All right. Hey, I'd mentioned our platinum and gold sponsors. Also want to take a moment to recognize our silver sponsor. I don't know if Angela's in the room, but I want to thank Cisco. Anybody here from Cisco? Thank you. Thank you for your sponsorship today. Now, before I bring up our next speaker, I want to tell you, this has been a little bit by design. Our content and even the order of it has been curated and organized by our artistic designer here with Hunter Newby. If you've noticed, we started at the ground and really quite literally the dirt. James, it's great to have you above ground today. And now we're going to move into the things that go inside that infrastructure and that foundation. And then, so there's a very intentional structure in how we're taking you through this content today. Our next presenter is with Stevens Fiber Group. He's the sponsor, as we said earlier, of our cocktail hour too. So Austin, thank you for that. We'll look forward to imbibing later. I'm talking about Alan Meyer. He's a 30-year veteran of the telecom industry with a background that includes experience in wireless, ISP management, engineering, and construction. Alan's networking and business development efforts have led him to work with some of the most recognizable telecom companies in the world, among them Google Fiber, Meta, Verizon, and AT&T. For more than a decade, he has been directly involved in building countless miles of fiber infrastructure and has proven himself a strong advocate for rural broadband expansion. Thank you for that, Alan. It speaks to a lot of folks here. Ladies and gentlemen, from Stevens Fiber Group, Vice President Alan Meyer. Thank you.
Which one? This one. Okay. Yeah. Well, thank you all for coming. Like Tom said, I'm Alan Meyer, Vice President with Stevens Fiber Group, and we're going to talk a little bit about the construction process. And I'm going to kind of go back and also hit on the importance of what we're doing here today. I'm here with Austin Stevens, the founder and owner of Stevens Fiber Group, and we're going to talk not just about broadband technology, but accessing it, because accessing it is really the soup and nuts of it. I'd like to start by saying thank you to Hunter Newby and Connect the Nation for inviting Austin and myself to join you guys here today. And we are here, like I said, specifically to represent the construction side of this project. But first, a quick introduction of Stevens Fiber Group. At Stevens Fiber Group, we're a full-service broadband construction company based in Kansas City, Kansas. Simply put, we build fiber optic networks. When you see the crews installing the orange pipe in the ground everywhere, tearing up your ditches, running through your neighborhoods, well, some of those guys might be our crews. Today, I'm going to talk about how Stevens Fiber Group, with our headquarters based in Kansas, but with nationwide experience, can help businesses here in Wichita and throughout Kansas and farther access the emerging technologies available through high-speed broadband. But before I get to my presentation, go back one. Before I do want to just briefly recognize that today is, like Tanya said, a very important day in American history. It should never be forgotten. In fact, because of the events of 9/11, there have been many incredible technology advances that often directly impact my daily life and yours. Some of these advances stemming from that historic day include advanced data collection and analysis, interoperable emergency communication systems, EMS, advanced imaging technology, and more. But none of this would be possible without the advances in internet technology and fiber optic broadband communications. Congratulations to all of us in this room. We are a part of one of the most incredible periods of human history. The evolutions of the Stone Age, the Iron Age, the Industrial Revolution, and now the Information Technology Age have each been critical to the involvement of civilization, and each of them have had their own unique challenges and corresponding solutions. Those have led us to our present time and future. Stone Age lasted about 3.5 million years. The Iron Age about 2,000 years. the Industrial Revolution about 150 years. And the current information age is only about 70 years old. This is how fast technology has caught up with the evolution of civilization. And in just the last 30 years of this information age, we have seen some of the most significant advances in mankind due to broadband technology, online entertainment, gaming, voice calling services evolving from copper lines to fiber optic, online services including finance, telemedicine, psychotherapy, learning courses, the development of smart cities, including New York, Boston, Seattle, San Francisco, Kansas City, and many others. Less than a year ago, Wichita announced their own smart city plan. It includes the installation throughout the city of sensors and cameras that will be able to monitor traffic flow and travel conditions. This plan will include a mobile app that will provide information about public transportation and even downtown parking availability. And all of this will be reliant on the Free State Broadband Network, supported by the state of Kansas. By the way, that is a bit of foreshadowing for another slide. And that's what we do. We help build things like that Free State Broadband Network. We're the guys that turn the dirt, break the concrete, and put the ducts in the ground that match up with guys like James's manholes. And all this technology are examples of the great, incredible opportunities created by the evolution of the information age and the growth of broadband technology. And now it's time to go further. To infinity and beyond, right? We are now poised to make the next leap into the information age in the tech era. In this new era of humanity, we are seeing tremendous advancements taking place in months rather than decades. And it is with this sense of urgency that we are all here. AI technology is advancing fields like manufacturing by improving efficiencies in process developments, medicine through greater image and data analysis and data processing, education by providing online classes and virtual educators. In telemedicine, AI and VR are going to combine to provide virtual assistants and chatbots to provide patients with support and triage services in remote cities and towns. VR will provide risk-free training procedures for the fields of medicine, education, and the military, as well as collaborative learning environments. VR is even being used today to train future professional athletes with programs in companies like XREPS. And all of us in this room should have the opportunity to take advantage of everything that the future of technology has to offer and contribute to it. But how do we get there? Here in Wichita, just like in Kansas City where I live, if we want to fly somewhere, we're extremely limited in nonstop options. Typically, if we want to fly somewhere like New York, for example, we're going to have to make several stops at larger cities, larger airports, hubs, that make our trips slow down. People in New York take for granted they can fly nonstop to LA. We can't do that here in Wichita. Well, large capacity data has a similar challenge: limited direct access. The current access model has us using retail consumer internet service providers to access the internet through their networks with many stops along the way. And while this model, it works fine for consuming, it's not great for producing. This model provides limited access and even more limited control for businesses with the need for high speed and high capacity data transferring. And in the instances where these consumer providers do offer high speed, high capacity data networks, they're very limited in their ability to provide access for most businesses. Just like adding nonstop flights to anywhere you want to go, the solution is to create secure, open access through a network of on-off ramps to the information superhighway. And I'm not talking about something that's cloud-based. I'm talking about a physical connection, a micro network that provides businesses with secure, direct, and unlimited access to the information superhighway via the internet exchange points here at Wichita State University. access for analytics, sound files, gaming files, movie files, medical information, education classes, syllabuses, manufacturing data, and much, much more. And all that AI, VR, and all of technology and innovation in general can provide. And the access for hospitals, universities, retailers, manufacturers, it all ends with fiber optics, but begins with the construction of a network that provides access to the information superhighway. That's what we do. It's a low-tech solution to a high-tech challenge. Stevens Fiber Group does this. We are experts in the construction of fiber broadband networks that carry the data that makes our lives better. Based in Kansas City, where we're considered ground zero for this gigabit revolution, we take high-speed broadband for granted. And we want Wichita to feel the same way. I gave a speech a couple of years ago at the Kansas City, Kansas Chamber of Commerce Annual Awards Dinner, and I congratulated the community and the leaders who had the foresight to lead the effort to bring high-speed broadband into the community. I highlighted the incredible business opportunities that high-speed and high-capacity broadband has brought to Kansas City, and it's done the same for several other cities. Startup incubators, the medical research facilities, the data centers. And that is what we want to bring to Wichita. Our solution. Fortunately for Wichita, the wheels are already in motion. The state of Kansas is currently undergoing construction of what is being called the Free State Broadband Network and includes a fiber access ring around Wichita. This ring will be an underground highway containing hundreds and hundreds of fiber strands capable of supporting all of your bandwidth needs for the foreseeable future. And our intention is to build the on-off ramp that you're going to need to access that superhighway. What we propose is a dedicated access that is secure and purpose-built for your specific technology needs, from your property back to the internet exchange point. Accessing the larger network and providing you with data transfer rates measured in microseconds. This concept can provide you with direct access to the internet exchange point without limitations of speed or capacity. At Stevens Fiber Group, we have the experience, the equipment, and the knowledge to build the access network that your tech needs require. We would like to work with you and your community to bring our crews and our expertise to build this network of on-off ramps throughout Wichita and ensure that you're able to access the commercial grade, future-proofed, high-speed, high-capacity broadband network that your innovation demands. And we're Kansans. Austin and I and our construction leaders at Stevens Fiber Group have years of experience working on projects for logos, including Google Fiber, Facebook, Verizon, AT&T, many, many more. We are completely and absolutely confident that we can effectively and efficiently bring our talents to Wichita and create a very positive project experience for this effort. And how do we make this happen? First, by understanding what is needed, the details. That begins with questions and conversations like the ones we're having today. If you are a business that is reliant on technology, we need to have a conversation. Let's work together to build this network. Technology makes manufacturing work. Technology makes hospitals work. Technology makes airports work. Stevens Fiber Group makes technology work. Thank you very much.
Thank you, Al. Yes. All right. Well, how do I introduce our next one? Wow. You're in for quite a treat. On any given week, this next speaker could be anywhere in the world. So to have him here in Kansas is quite a treat for us. I want to welcome Ivo Ivanhoff, CEO of DKIX and the chair of DKIX Group AG. With 20 years in the internet and telecom space, Ivo has been recognized 3 years running for Capacity Magazine's Power 100 list of industry's most influential leaders. Since joining DKIX in 2007, he has driven the company's global expansion to more than 50 internet exchange locations worldwide, shaping interconnection across Europe, the Americas, Africa, the Middle. It may be quicker to say where he hasn't done it. This year, a great celebration marks the 30th anniversary of DKIX, a milestone that reflects its enduring impact on the global internet. Ivo's vision also extends to education with the launch of the Global Interconnection Academy to train the next generation of experts. Fluent in 4 languages and with a background in law and business, he brings both strategic insight and global perspective to the future of digital infrastructure. He's going to need the whole front row here. He does not stand behind the podium. You're in for a real treat, folks. Please welcome Ivo Ivanhoff.
Thank you so much. Thank you. A very good afternoon, ladies and gentlemen and friends of digitalization and digital infrastructure. Thanks for having me here in Wichita. It's my first trip to Wichita, definitely not the last one. And what a start, what a start. It's an amazing one. Thank you. Thank you, Tonya, for driving this innovation vision for the Wichita State University and the great tour you gave us today on the campus. And I was so impressed. Amazing organizations are here in Wichita. And thank you, Hunter and Tom and the entire CN Connected Nation teams for this great project. Now we all saw what will happen under the ground, how the fibers will arrive, how the data center will be built. Now there's something missing. We need to put a heart to this data center because otherwise the data center will be a closet for servers. And we want to change this. And the heart of a data center is the interconnection platform, delivering connectivity, density of networks, and building ecosystem. This is what DKIX does around the globe for 30 years now, with a great team behind, different nationalities. We won a lot of awards I'm very proud of. We're present in so many different metros around the globe and serve different type of interconnection services. I bet there are people in the room, they don't have a clue about an internet exchange. Those who have, there are just 2 slides explaining, so it will not be boring for you. But those who do not, see, this is what happens where there is no internet exchange. We have so many networks around, and they all need to interconnect to deliver services. If they interconnect bilaterally only, this will be the picture, and this is just an example using probably 12 dots only. Now imagine what how the example will look like if you use 100 dots, 100 networks, what will be 1,000 and more. So this is what an internet exchange provides. It cleans up the picture, creates it very efficient, highly aggregated, cost-effective, and extremely secure. This is what an internet exchange does. That is a great analogy to an internet exchange using the example of an airport. And Wichita has a lot of airports, 17 airports, but not a single exchange. We will change this. We will introduce the internet exchange, which it deserves. And the analogy goes like this. An airport operator takes care of security and reliable processes and systems allowing airlines to land their aircraft and take off and, of course, exchange a lot of passengers and luggage. And now, if we replace the airlines with networks, internet service operators, cloud service operators, and replace the luggage and the passengers with data packages, this is what an internet exchange does. We operate airports for the internet, creating a very, very secure ecosystem environment. And this is how the ecosystem of DKIX looks like today. 60 different markets around the globe, present on 5 continents, as Tom mentioned earlier. We're very proud of this. More than 4,200 networks are connected on the different DKIX platforms, and this stays for the largest data center and carrier-neutral internet ecosystem on the planet. And Wichita will become part of this. I am so excited. In North America, we do operate already in 7 different markets. Ed D'Agostino is in the room. He's my director for North America, and we will add more and more markets, building the true digital America, all together with all the partners we do have. And I want to give you an example of a city well known. What can happen if a healthy ecosystem is created? We started the business in Dubai in 2012. And now you can ask me, why these guys does compare Dubai to Wichita or with Wichita? And there is a good reason, because in 2012, Dubai didn't have carrier-neutral data centers. Dubai didn't have an internet exchange. And 14 years later, I'll show you what the creation of an ecosystem, having data center, carrier-neutral data centers, having a carrier and data center neutral internet exchange can deliver to the economy, to the region, to the city. We compared a lot of data using data from 2012, comparing to 2022, when we did celebrate the 10 years anniversary of DKIX. Look what happened. This is a great example what starts to happen if an ecosystem is in place. In 2012, only 3% of the content that is required to be accessible for the users was present in this region. 90% was outside. Like comparing this to the US, 90% of the content is on the East and the West Coast. But this doesn't work. We have to bring the content where the users are. And this happened. Now, 90% of the content is now in Dubai. This is another example of what happens if the ecosystem works. The cost for the affordability of services and digital innovation increases dramatically. You see, IP transit upstream, the price was 10 years back around $70 to $80. This is incredibly high. Nowadays is $1. And does anybody complain from the operators? No, because they got so much business in place that overcompensate certain cannibalizations, if any. And it's great for businesses and people in the region. And last but not least, latency, milliseconds. We will talk a lot about this today. 200 milliseconds was the status in 2012. Speed to top 20 content. We changed this to 3 milliseconds in 2022. And this makes the difference. Nowadays, applications cannot work on 200 milliseconds. We need the lowest latency possible. Another example for what healthy ecosystems contribute to economic growth. I'll give you the example of Frankfurt. This is where our business started 30 years back. In 1995 back. Now in 2025, this year, we produced a study that created a matrix about the, I would say, the power of the economic growth. And Frankfurt has been ranked on this study as #1 worldwide with this type of KPIs. More than 1,000 networks, 24 data centers, 18 terabit of traffic live. What does this mean for the economy? It means this: contribution of more than 4 billion euros to the GPR. This is amazing. The economic growth in Germany receives 4 billion just out of this ecosystem and contribution. And this is because of improving the resilience on network and the quality on digital services. Now, let's talk about latency. And latency, I call, is the new currency. This is so important today because without latency, without low latency, we will not receive proper digital services. Is there someone who watched the latest Mission Impossible movie? There was this evil entity, they call it. And the evil entity wanted to destroy the world, the evil digital entity. And the code of this entity needed to be destroyed with a device. And there was a pickpocket expert, and she needed to remove this device with the code within 100 milliseconds. This is what they told it. And she asked, how fast is this? Said, faster than a blink of an eye. And this is why we need to talk about latency. Now, let me put the latency perspective on different applications. Speed of a blink of an eye, 100 milliseconds, depending on the day. If you have a hangover, it's higher. Then, standard applications on the internet, streaming, they require nowadays better than 65 milliseconds. If we talk about 4K high def resolution and live sports streaming, we're down to 30 probably, and better 25 milliseconds. Online gaming, real-time online gaming, requires better than 20. And if we talk about the latest applications on the mobility side, on robotics and digital healthcare, we're talking about even less than 1 millisecond. So this is what we need to achieve to make applications available and create the best experience for users. And we will achieve this. Now, these are all terms, as you can see, we all know about those. AI is the buzzword everywhere. And all the others, what do they stay for? They stay for the immersive internet. The immersive internet is literally digitalization of our life. And this digitalization of our life will require certain capabilities. And we predict that the infrastructure of the future will require the speed of human perception. Why? I will prove this in a couple of minutes. Oops. So we are talking about the perception of our tactile information. We're talking about video information and audio information. We're talking about how our brain functions. And this is what the immersive internet should achieve, should deliver in a way using the best infrastructure possible. Therefore, we are talking about a new internet requirement. AI, and I use this example based on robotics to display what this new internet needs and what type of infrastructure we will need to deliver this new internet. AI as a benchmark to set the borders of the new internet. Let's look inside of the AI, inside of a robot. If we imagine a robot is the device, and we need to look how this robot can function using AI. There are two different scenarios, obviously. The one is the training, and the other one is the inference. Inference is even the more exciting one, because inference is AI in action. Inference provides the real action behind the applications, behind the models. You see, the AI training consists of data computing and AI, the models, the LLMs. The inference consists of three elements: transmission technologies, the devices, and the models. And all this leads to a big data journey. The data journey between the devices, between the models, and the transmission technology, ending up to the robots. What is important here? Important is to create the controllability of this data journey through safe and secure infrastructure. Now, and this needs to happen everywhere, because we have data everywhere. Computing power is somewhere. Talking about the training training requires big pipes, compute power, and latency be that important. The risk is kind of manageable because if there is an outage, the training will not be harmed. But if we talk about the inference, and this is what I call it, the AI triangle, we are talking about very low latency requirements. We're talking about a high risk protection requirement. This is what the AI inference requires. We need to deliver this everywhere, following the model of transmission technology on-site in the best way possible, connecting to devices on the lowest latency level possible, and serving at the end the models in those devices. Now, I want to bring this into perspective. Unfortunately, I do not see the icons there, but those icons, they stay for the perception, the tactile information, the video information, and the audio information. And if we think about all this together, they need to be managed. They need to be delivered to the robot, to the device, to the car in the best, with the best performance possible. This is what we call the routing of different AI models. Now, unfortunately, the format doesn't deliver a lot of nice pictures, but I'll try to explain better. Now back to the latency. Standard applications, we talked about this. They do require, 65 milliseconds, right? Now, the next one is interesting. Actually, we should have seen here a hand. A hand stays for a tactile information transmission. How our brain transmits tactile information. The information about cold, warm, soft, hard requires better than 18 milliseconds. The next one, 13 milliseconds. What do you think this stays for? It stays for the video information, how we perceive video signals in our brain. And last but not least, less than 1 millisecond is the audio information. So if we want to have a great immersive internet experience everywhere, the infrastructure delivering this experience has to meet the lowest number. Otherwise, the application will not feel natural. The robot will not function like a human being. This is the infrastructure we need. Put this in perspective to distance, because latency, speed of light, results to distance. What we see here, 3,000 miles, okay, not important for what I'm talking about. But this one, we're at 1,000 miles if it comes to 20 milliseconds. Let's see what will be the requirement for the full experience. We are talking about a distance between 50 and 100 miles from the application, from the AI inference model to the device, to the user. Therefore, Wichita deserves this infrastructure so much to deliver the next generation of digital experience for businesses and for users. So, thank you. So the slide looks normally different, but it's a summary. As I explained, global integration is good as needed. Global integration is important, especially if it comes to certain training models and data that has to be used for training in certain regions. However, we need a very high level of localization, as local as possible, as globally integrated as needed. And this is what we will create for Wichita, bringing the gravity, IP gravity, building healthy ecosystem in this way, with high interoperability, very close to the edge, distributed, and helping companies, and this is very important, to build their own internet. built their own ecosystem they need for their purposes: manufacturing, mobility services, retail, logistic, finance, you name it. And these are the three elements we want to meet, we will meet. Simplicity, the simple usage of digital services needs to be achieved. Security and compliance, extremely important, and the highest level of performance needed. This is what we will introduce from day one at the Wichita Internet Exchange in the IXP facility. The first-in-class AIX, DGX introduced last week, literally, will be available from day one in Wichita, serving both, and this is very important now, the training purpose and the inferencing. Multi-routing of agents, of millions of agents, will happen on the platform. This will allow enterprises using different models, thousands of models, to use these in a very secure, highly aggregated, cost-efficient, and highly performable way. And the training is also very interesting. We do introduce next year the first-in-class GPU as a service community build using the Ultra Ethernet Nokia technology. What does this mean? We will be able to bring together different GPU installations into one virtual environment, allowing enterprises to use as much as they want and can, without limits, without borders. And this is the AIX for all types of industries. We call those blue. I'm sorry, the format is not, but literally we're talking about all the different type of industries will be served here on site in Wichita, not from the East Coast, not from the West Coast, here on site, building digital America. And this is, for me, a map that should change. And this map changes today. We introduce this dot on the map. And I'm very, very, very proud of this special day, and will be even more happy and proud when next year we will turn on the light on the platform and open the first exchange in Wichita, the first in time, growing the ecosystem here for great economic prosperity for all the users in this great region, but also for all the businesses supporting their prosperity and business growth. Thank you so much for your attention.
Yeah, all right. Our apologies for the formatting difficulties we had. We'll get that cleaned up, certainly, as we make content available post-conference. So thank you, Ivo. All right, Ivo mentioned strong teams. Let me draft off that for a minute. Just as DKIX enjoys a strong team. We have a great team. I've told you about our sponsors. Let me tell you about our more programmatic partners here. There's 16 listed. If you haven't seen them already, they're there on our banners. I'll just do a quick run through. We've got Stevens Fiber. We've got the City of Wichita, NetApp, Tordex, Flagship, Wichita Chamber of Commerce, the Kansas Department of Commerce, WSU Tech, Moonshot, Nexus, IM Data Center, DKIX, Newbie Ventures, Groover Labs, Hydra, and Sedgwick County. So thank you for our program partners. All right, well, let me bring up another distinguished guest here that we have to regale you today. Now, remember, we were out in the street, we came in under the ground, now we're in the building. Ivo brought the heart. Among other things, he brought the heart today. Now we need to talk about, we heard about GPU as a service. Let's talk about some of the things that actually begin to transact and happen inside this wonderful new building that we're building. Our next presenter is with Moonshot Energy. He is, again, a gold sponsor for today's summit. Brian Lubin is a seasoned infrastructure and finance executive with more than 20 years of experience in data center development, renewable power integration, and institutional lending. As the Chief Operating Officer for Moonshot, Brian leads modular AI data center deployments powered by renewable energy, including GPU cluster rollouts, standard power conversions, and large-scale offtake agreements. His career spans high-stakes project finance, utility negotiations, real estate acquisitions, and power purchase agreements, uniquely positioning him to bridge the gap between infrastructure operations and private equity capital deployment. Please join me in welcoming Brian Lubin to the podium.
Yeah, it's okay. Awesome. Thank you, everybody. Tom, great job. There's a lot that you just said about me. Some of it's true, some of it's not. I want to first say thank you to Tanya. This is unbelievable. I've never seen a presentation like this in terms of this brand new, beautiful campus that you guys have created. And the opportunity, I think, that sits in front of us is bright, and using Moonshot's phrase, to the moon, of one of the biggest things, right, that I think Wichita is going to see for quite some time. So great job. Piggybacking off of Ivo's idea of the interconnection being the heart, the GPUs are the brain, right? It's what drives, it's what allows us to move forward. It's what allows us to be able to grow and expand and be thinking and mindful of AI in itself. And what that means is a difference between being able to deploy it, right, in Wichita or in New York or California or Texas. So my story is a little bit different. I come from San Diego, California. I now live out in New York. Everybody asks why I did that, and it's because that's, for me, the passion, right, the drive, the energy. It allows me to succeed and grow. And it allows me also to be here today. Without that, I wouldn't have met Hunter and be able to present, right, this opportunity that I think is so unique and well-fitted for what you guys have built. The tech park here that you guys have, I think, is beyond innovation, right? You will never see anything like this in NYU. They don't have the ability to do it, right? And the foresight to have this here, I think, is incredible. So my background, like you said, is real estate and credit risk, right? Father was a developer turned financier, crashed in '08. So I watched the rise, I watched the fall, right? Humbling, and also gave me a mindset of risk in general, right? What does it mean to acquire wealth, right? What does it mean to stand past it once that goes away? And so I came to New York, and I took the exact opposite route. I went to full W-2, went to the corporate banks, and I was like, I'm gonna be as strong as I can be in this sector. And we just got married, and I stayed in there for about over a decade. And what I did was I focused on credit risk. So I was at Morgan Stanley, ran their ultra high net worth lending platform for the New York office, became a chief credit officer at Bank of New York Mellon, where I was actually created a lending platform inside of that bank. So compliance, OCC, CFPB, lending, that's me. I'm a dork at the end of the day, and I'm an underwriter at heart. So I love to live in the weeds, and numbers have meanings to me. And with that, I went to Wells Fargo and ended my corporate tenure there in 2021. COVID hit. We were welcoming our third kid. We just moved into a brand new house. So I thought, what a great time to quit my W-2 job and go start my own company. And that's what I did. And I ran into Ethan Ellenberg. So there's two companies with Moonshot. Moonshot Core is what I call it, is a critical infrastructure manufacturing company for data centers or for power, right? In order for you to turn on these lights, have this presentation, you have to acquire the equipment. So similar to picks and shovels, right? We are the same thing, but in actual electrical components. And with that, we are able to grow and develop data centers. And since 2021, Ethan, where I met him as well, back when I started my company, has deployed just over 3.2 gigawatts of equipment throughout the United States. And think about that in perspective, right? A megawatt powers 1,000 homes, right? A gigawatt is 1,000 megawatts, right? So a substantial amount of power is going in, obviously, which is why we're all here today, in order to grow it out. The crazy piece that comes about, right, is does data centers actually equivalent to power generation? Yes, but does it also equate to the opportunity for you to grow in terms of the GPU and the server and the AI growth, which is what I'm gonna go over. So the way that it worked is, he came to me, he said, Brian, come in and start working for Moonshot Energy. So I started working and going over Moonshot Energy last year. And the initial launch was supposed to be an edge compute data center, right, which is small, sub 20 megawatts data center. The cost of that, though, is substantial. The capital requirement is substantial, and the risk is high in terms of risk and reward. that was not going to come to fruition. So we said, all right, let's do GPU as a service. Basically meaning buy servers, right, and deploy them. Sounds easy, right? Buy a piece of hardware, plug it in, and make revenue. Not so easy. And the reason is these servers are substantially cost heavy, and the capital requirement is large. So who knows CoreWeave? Raise their hands. Anyone know CoreWeave? Yeah? Anyone know Lambda? Okay. Anyone know OpenAI? Awesome. Anyone know FluidStack? Oh, good, there's a few. So what I just went through, right, was a $50 billion company, right? Another $20 billion company, right? And then I went to the last one, which is mostly people don't know. So the ones that raise your hands are definitely in the space. The ones that don't, right, they are a GPU marketplace. They just closed a deal with a company called TeraWulf, which is a data center developer, and they were backed by Google for $1.3 billion. They're doing a 160 megawatt deployment, and that 160 megawatt deployment is based solely upon the fact that FluidStack is able to buy and procure those servers and then lease them to generate revenue. Google came in and said, no worries, we got your backstop. Just in case if you don't, then we will take care of the lease to the data center. That is a substantial ask in faith, right? But where does that show the market? Where does that show the ability to do something like that here, right? Where the company that we're running now at Moonshot Energy has done that in a bifurcated way, right? And the way that it worked, we did a proof of concept out in New York, thanks to Hunter's help. And we have 8 servers right now that are running out of New York. These are B200s, and the company is Averest as the OEM. And right now, these have been running for the last 120 days as a proof of concept to make sure that what I just walked through of procuring the servers, leasing those servers, and generating revenue is actually positive. And that has been done here. They sit inside of one of the only data centers and colo providers in New York, it's in Brooklyn, in which Hunter sits on the board of directors on, which is why we were able to use this as the opportunity. What it does for me, selfishly for Moonshot, is that it allows capital stacks to come and touch it, feel it, see it, right, as opposed to just looking at it online. That's one aspect. But what the other aspect is, it allows me to grow, right? It allows me to be here today, to present this opportunity where we would love to be, right, in an area that we all know you have power. That's not the issue, right? It becomes what we've just been walking through today, succinctly, as Hunter's been able to build this model, right, of all the way to the dirt, all the way up to the actual data center itself, and then being able to provide the servers as a GPU as a service model, right? So as that GPU as a service model grows, it becomes a volume-based business, and then you continue to grow. You all know who CoreWeave and Lambda is. It's the same exact thing, right? But it's on a lower grade. So you see deals right now that are going in place. Microsoft just launched Nebius, right? Or not launched, but invested, I think, $17 billion into Nebius. These numbers are ridiculous. These numbers are unbelievably out of control because it takes years to get there, right? But that's not something that is actually tangible for 99% of the people that are trying to do this. So there is a totally other world there, which is GPU as a marketplace, in which Hydra is my leasing, right? So I think about a server as a apartment building. Each server has 8 GPUs. So just like an apartment building has 8 apartments, if you were to compare, you want to keep that occupancy high. In the server world, we use utilization, right? And that utilization basically is our revenue. GPU marketplaces, which is Hydra Host, is my client in which I hired to go and lease my servers to generate that revenue, take my risk away, to make sure that that utilization stays high. Now, the competition that we have right now in the marketplace, as you see, I'm not going to go compete against a $17 billion investment from Microsoft, right? I have to find that myself. So Jensen did a great presentation like a couple months ago in GTC Paris, in which Hydra Host is one of the top 5 GPU marketplaces that are currently out there in the world. And FluidStack was number 1. And what just happened to them, right? They essentially are now taken out by Google and TeraWulf because they have to fill 160 megawatts worth of servers. With potential clients, yes, no, no one knows. With this model, right, it allows us to do step by step without taking too much of a risk, and allows us to actually grow, but at a market-based clip. And the market right now demands certain pieces. So your university, which walked through from Shocker, which was unbelievable. Justin was a great innovation and visionary of what he built out there. And they're running, you know, that entire software base, or the entire place based off of just, retail computers. And I think it's amazing that there's a limitation there and an opportunity to bring this in with everything that everybody's presented today, in which latency and fiber and interconnection are the requirements in order for you to grow up to this next scale, right? You have the land, no question, right? You have the innovation, you have the vision, more importantly. But what comes after that, right? This becomes the final product of being able to utilize these AI servers that everybody hears about, or if you use ChatGPT and open up everything and say, tell me that I'm looking good today, and it'll tell you absolutely. And you tell me not to, it'll say you still look good, because it wants you to know that it only gives you what you want to hear, right? But the B200s are the example of what we decided to go with. The rack that we have right now, this rack is a $3 million investment, right? Just in the servers alone. It doesn't include power, it doesn't include anything else. Just for me to sit there and try and run this is a $3 million investment, right? As you grow up to that next phase, a megawatt, right, is essentially 80 of these servers, right? So it's a $30 million investment just for a meg. And you hear on the news, people are talking about gigs. So you can think about the size and scale of what people are doing and growing into. So as we decided to go and move forward and take this risk and show the opportunity, we went forward with Hydra as the off-taker, because they are what we believe to be a critical infrastructure data center in order for us to help grow and launch GPU as a service. Do you have a microphone? I don't want to... Test. Hey. So I want to just walk around for a second. So down here, as we start to see, these are the prices that people pay in order to utilize the servers. And they call it a GPU per hour, because that is the value that you have to lease us from. And those values range from a couple dollars, right, all the way down to cents, depending on the server that you're using. So we decided to be the first in Hydra's 24,000 GPU clusters to launch the B200s. We took the risk. I jumped off basically jumped off the cliff and said, "Catch me," and they did. It was a huge, gamble for us, but that's how small this world is that we're playing in terms of the AI race, right? You might see a lot of stuff on the news, you might see a lot of things that people are doing, but the reality is it is less than 1% of people that are actually being able to get to that stage to get it done. Only because all the pieces that we just walked through has to be done. It takes a village. I can't do this by myself in no way, shape, or form, right? And the team that Hunter has put together and Tanya have put together is what's going to bring Wichita, right, to an opportunity of growth of GPU marketplaces, right? Or GPU internally, right? In order for you guys to utilize AI, these are the servers that are going to be the future. Now, NVIDIA itself has a full other platform, right, based off of, oh, great, B200s are out. Awesome. By the way, in like 6 months, B300s are coming out. And by the way, in a year, right, it's a whole other platform. How do you keep up? What does that look like in a risk model of return on investment? And essentially what's created, the capital markets have caught wind of this and said, look, if we're going to invest billions of dollars into this, then we have to have a run ramp, right? And that run ramp is about 3 years. We call it technology decay. How many people have had a new phone in the last 5 years, right? Same kind of a thing. So as you continue to grow and as technology continues to grow, you have to be able to keep up with the market. And in order to do that, I go back to what I said before, is we grow at a market-based clip, right? I cannot go and purchase $100 million worth of an equipment without knowing that the market is there to sustain it. And that's the next step of evolution of where you guys have an opportunity to come in, right? You already have a huge demand on campus right now. That's one piece of the puzzle. The next is you guys purchase those servers. If you have, utilization, right, of let's say less than 50%, there is a value, right, that is lost. So you have the opportunity to go resell that market and the availability back to the marketplace. Anybody can do what I do right here, right? I'm not special in that regard. I was just crazy enough to put the pieces of the puzzle together to try and do it myself. And it worked, but my gosh, if it wasn't painstaking. And that risk and reward is where we stand today. I think with what Wichita has put together, I'm just going to show you what this looks like. With what Wichita has put together, offers a unique perspective of the universities in itself. There is no other university that I've seen that has the foresight right now to do this, only because of everything that we just walked through today has to be done, and the red tape and loop and compliance that you have to deal with and regulations are unfortunately just too high. So I'm excited to be here. I'm excited for the opportunity to grow with you guys. And I really appreciate Tanya and Hunter for putting this together, and Connect to Nation. Thank you guys. The other guy didn't come. Do you want me to keep on going? Aaron's not here. Okay, cool. All right. I think I might be back. So everybody take a break and yeah. Thank you all.
All right, we're going to take a quick 5-minute recess here. Get yourself some refreshments. The facilities are there to the left, and we'll reconvene here in about 5 minutes. Thank you. All right, folks, we're going to do a 2-minute warning. If you all want to grab your last soda there or find your seat, we'll get started here in about 2 minutes. Hunter, for our next one, we're going to Hunter, he's not listening. We need to get the 3 chimes. That's what we need, right? Isn't that the polite way of bringing people back together? Maybe we should do a $1,000 grand prize drawing. That'll get them back in here, right? That's what. Maybe. Must be present to win. Right. Yeah. Shoe them in here. We probably have a room full of Wichitans, but Tanya, maybe while we're waiting, Tanya, come up here. Yeah, well, let's impart something unique to WSU culture here. While we'll entertain folks as they come back in. So now, what is the WSU rallying cry? Is there one? Is there a battle cry for the Shockers?
I don't know. Who's a Shocker here that knows
Any
the
Shocker
battle cry?
want to lead us in the?
I mean, we have
in the battle cry.
We don't want to go to war. I mean, but that's Villanova's, and we stole it from them.
Oh,
so.
is that right?
Yeah.
Okay. All right. Maybe the background on the WUSHOC, what it is.
Yeah. Who knows what WUSHOC is? We have all the Wichita people here. So for anybody that is not here, WUSHOC is literally a shock of wheat. Yeah. So our students, many years ago in the summer, their jobs were shocking wheat. They went in the wheat fields and cut all the wheat and shocked it into shocks. And so one of our students drew the first WUSHOC, which was a shock of wheat with a very angry face, and that became WUSHOC. And then there's an evolution of he's a kinder WUSHOC now. He's got a smile, not quite as angry. So there's an evolution of that picture of him, though. But that was a student-created mascot.
He's working through his anger.
Yeah. Right. Even though one of our athletic slogans is "Play Angry." And that came from Xavier McDaniel, one of our famous basketball players that came back to really pump up our team when we went to the Final Four. And he said...
That was the undefeated season, wasn't it?
It was.
Yeah.
We had a great season.
You've ruined enough
I'm
brackets.
pretty sure we beat Kentucky.
Well. That was a little on the nose. I was going to say you've ruined some brackets, but since you decided somebody's playing angry. Thank you, Tanya. All right. The insights into Tanya Witherspoon, the many layers of Tanya Witherspoon. So great to have her in our orbit. All right, well, we're going to go ahead and get started. Those of you that are out there, come on in. There's always room. All right, by the way, Brian, it's hard to come back from a great break like that, but let me tell you something. I had the distinct pleasure of seeing those B200s live in operation, along with Brent, what is it, about a month ago? Folks, I can only describe it as a cliff dive and a rock concert all in one. It was, and it smelled like glory. It was wonderful. And so you guys are soon to inherit that type of opportunity that right now is existing in cities like New York. So, okay, well, so we talked about Moonshot, and you heard some reference to Hydra, Brian's great partner. So let's bring up our next presenter. He's a serial technology entrepreneur, writer, and the CEO and co-founder of HydraHost, a venture-backed AI data center services and management company and one of the world's largest GPU management platforms. He has written extensively on artificial intelligence, trade policy, and technology competition, and is a regular contributor to the Wall Street Journal and the Fox News Network. He's also co-founder of Fabius Labs and a Foundation for American Innovation, and serves as a policy and AI advisor to a number of elected officials and heads of state. Ladies and gentlemen, it's my pleasure to welcome to the podium Mr. Aaron Ginn.
Use that. That one right there. This one? Oh, okay. In case you want a more artificial image of me, that's me. This is the real life version. So yeah, I'm here on behalf of one of our VPs, Nick. Susan's been doing a lot of work out here in Kansas and also with many of the partners listed. So I am the CEO and co-founder. Nick, unfortunately, I had to force him to go to a conference I didn't want to go to. So you have me. But I am from the great state of Texas. It's the big thing at the bottom of the map. But I lived in California for about 10 years. Currently, we're basing the operation in Colorado because I love the Mountain West. And we started this company around 5 years ago with this thesis that data centers were going to be, the data centers were going to be essentially scarce, and that we saw a shift happening in the infrastructure layer that was going to transform the way the cloud was going to work. And our first data center deployment was in Phoenix, and we started working with a tier 4 data center there. And we were trying to migrate people away from the cloud, and we basically saw all these problems in which the data center was not in a position to serve end customers. Today, we are in over 50 data centers in the world. We manage around 50,000 GPUs. We're in 15 countries. We also are the key provider to, let's say, notable telcos like FTP in Southeast Asia. We're doing a project with SoftBank. In America, we are the go-to-market provider for Charter and Verizon. And we have a number of key sovereign accounts like President Bukele in El Salvador, and a couple projects in the Gulf region that will be announced probably for the end of this year. And the thesis of our space, or thesis that we saw in the space, was essentially that there was a large amount of abstraction that was built into the CPU cloud that required that commercialization happen at that layer. And that as Jensen, primarily Jensen, continued to iterate on his next version of accelerated infrastructure, that there was going to be a significant change in which how things were going to transact. You can imagine that if you, let's use, since Airbus is here, we'll use a commercial airlines example, that under the CPU cloud, imagine that Airbus sent a plane with no software, and that software had to be provided by Azure. And as y'all know about any type of manufacturing today, that if you have a hard material asset like an airplane, the software actually becomes the key integration point into which you have interaction, because we're predominantly a software-driven world. Tesla, same thesis, where the hardware itself is actually a complementary good to the software. The software is the core product, which allows Elon to continue to build his company really around being a software-enabled company that has hardware as a byproduct. Apple is another example of this. So what Jensen was doing was essentially continuing to iterate on the hardware layer until he can eventually become the Apple of silicon, or become Boeing or Airbus that actually had software built into it, as if the avionics itself came with the airplane. You get the airplane, you're done. That was the direction that we were seeing in the infrastructure, in this next generation of accelerated infrastructure, which actually created the ability for OpenAI to even exist. First cause was infrastructure, second cause was Sam Altman. And so as this shift happened, providers that were, let's say, in Kansas or even in other secondary markets like Ohio, a little bit, Colorado's a little bit of a tier 3 market, as in lower tier, not tier 3 as in data center. What we saw was the fact of like these providers are now going to be in the position of providing an end good that previously they weren't before because of the work that Jensen was doing, where he was compressing the stack to him, where he can become a transaction point, which means that everything deployed into the data center becomes a commercialization layer. There's no more cloud, there's no more any of these like big public cloud companies. You just go to a data center and get what you want. And that's essentially what we're living in today. The reason why we have all these data centers built everywhere in the world, second cause is AI. First cause is a completely change in infrastructure. The monopoly that was the three guys is dead. Jensen killed the public cloud. So that's why we're all here today. So you should thank Jensen by buying some NVIDIA stock. Maybe we'll be an $8 trillion company one day. So previously, there was, as you see with the chart, AWS had to be vertically integrated. So you had to do all these like magical things to make CPUs work. Even just talking about like the basic hardware of how a CPU is delivered, is the reason why you needed all these services built into the actual hardware of a CPU was because, simply put, the management of the CPU and the customer workload was commingled together. So if you had, let's say, 256 gigs of RAM, you had to share that between your actual management of the product and the actual consumer workload. So you needed to virtualize the thing. And so the first step that Jensen did was he separated that. He developed what we today call the HGX, DGX, future BGX baseboard, where everything that is outside of Jensen is passively running the machine and to transitions you into the actual Jensen Gold, which is the baseboard. So that's the thing that looks like the eight cards. It rises up. It's the most expensive part of the server. It generally occupies like 80% of the cost of the server. So that was like one of his first steps he did, which is like he separated at a hardware level between the CPUs on the server and the GPU baseboard. So therefore, management workload runs on the CPU. That's the Intel AMD stuff. Now he has the new version, which is called Grace, which is doing this. So that's a Jensen-owned CPU. So that first step, from the ground up, it's basically agnostic, because the workload that's going into the management side, the workload that's going into the customer side are completely segmented. Then he started doing more things. He basically, he started doing his own NICs, he started doing his own cables, he started doing his own networking gear. And the idea is that the data center itself can basically be in a position to where it can serve an end customer, and all these become resegmented in the stack. So that's what we're seeing happening in the market is tooling is becoming segmented outside of public cloud. You're seeing marketplaces being developed. You're seeing NVIDIA providing software that previously only resided in the public cloud. And so what we do is essentially we provide an API that unifies all the data centers in the world. We want to be the largest AI factory API in the world, to where if you're launching a data center user API, you get connected to all these things. But essentially what's going to happen is that a lot of these cloud companies are actually going to end up becoming SaaS platforms. And that what they're providing an inference product or some form of like helping you train, they're actually not going to become an infrastructure company, because in a world where you're disaggregated from the actual fundamental asset and the actual underlying asset is the transaction point, the CapEx actually leaves. And this is why you see with like probably like this building. This building was probably land's owned by somebody else, building is owned by somebody else, managed by somebody else. That's the future we're going to, where the actual infrastructure of the data center becomes completely owned by somebody else, like a REIT, basically, where that side of the stack becomes experts at collateralizing debt. And then there's a higher level software abstractions that really are just EVs, or so the enterprise value of that company is high software margins. So in a verticalized thing, all that was commingled together because the underlying product, the CPU, all of it was commingled. Like as in you had to, from the base start, separate out at the CPU level, customer and management. But in this future world where all that's already segmented out of the box, this whole new world is being built. And so if you're in here thinking, well, why doesn't AWS, Google, or Azure, go do this yourself? Just go look at what they're doing. They're signing deals with local data centers. They could do it themselves. Why don't they want to do it? Because they want to hold the debt. And they also see in their own data that people aren't staying anymore. They're coming, using Jensen, they're using AMD, and then they leave and they go somewhere else. It's becoming a highly disaggregated, highly disparate market. And you talk to AI companies, and I've lived through, like, we got in Silicon Valley during the mobile boom. We talked to any tech companies then, nobody rented from more than one provider. Everyone was on one. Talk to any AI company today, all of them are renting from like 5, 10 different people. They're looking for price here, they're looking for location, they're looking for a different type of GPU. So they're going for chip, they're not going for cloud. And that's where essentially Kansas can enter into the market that previously was inaccessible, is that all this is being refractured. And the more that you pick a part of the stack to play and you really excel at that, the more people will be drawn to you because this stuff is not as location dependent as it used to be. And it's also highly, it is no longer driven by any type of vertical type of motion like previously with the CPUs. It's going to be continually disparate where you can just install gear, launch, and people come for gear. They don't come for cloud. And so you see this actually in the price of the GPU, that on the hyperscaler side, they have to run at a higher expense threshold. One is that they have hundreds of thousands of people. Two is that they're operating in basically old types of tiering of data center infrastructure that's very unlikely to actually continue for accelerated computing. And the third is that if you think that, really you're just coming for Jensen Gold, then you can always offer Jensen Gold at a better price. And that is something that hyperscalers just can't win at. And so what is their response? Well, of course, build their own silicon. Because if they offer their own silicon, they can basically provide a loss leader into their cloud fabric that actually makes you stay. That's why they're doing that. Before they had some experience with their own silicon, but in reality, it was like a secondary byproduct of their business. Now they have to do it because nobody's staying. Everyone's coming for Jensen, then they leave when they're done. Once they spend that $400,000 worth of credits, they go. And so they have to compete at the silicon layer. This is why they're building their own silicon to try to make it as a loss leader so they can continue to compete in the market. So we, as a universal API, we've been focusing on continuing to automate data center infrastructure so that it can basically be as turnkey as possible. And we provide all the infrastructure code environment, assuming all these things are happening in the market, that you're going to go to a data center because it has power. You're going to go to a data center because it abides by some sovereignty aspect. You go to a data center because it's cheap. All those things are actually get to be expressed now into the infrastructure market because public cloud is dead. And we're going to be serving markets like Wichita. We have half of our data centers are here, and they're all in places that are super fun and interesting. Working on the sovereign data center in Alaska with the state of Alaska. And to see the fact that something that previously resides to Northern California, Phoenix, and Virginia now can go to the world. Now that American manufacturing, American silicon can be occupying all these different data centers around the world. It's a very exciting time to be an American. To see that the Gulf region is willing to spend $1 trillion on not just they love weapons from us, but now they have something that actually can transform their country. They can provide better education, better healthcare, better government services, and that America can be the footprint, peaceful footprint of soft power expression so where they can be a part of this revolution. Like America made this. So we also feel very, very, very proud, as well as this type of revolution of the next type of infrastructure is going to impact everyone in America, not just those who are Ivy Leaguers or those who live in San Francisco, where I used to live. It's really bad. Don't live there. It's very, very bad. As you can tell, I vote the right way. It's going to be to all types of Americans. And so states like Kansas can actually enter in this, be extremely competitive. And I hope that you do undercut Northern California. I hope you do undercut Virginia. Because customers need this. We want AI to be cheaper. Our product assumes GPUs will continually get cheaper and cheaper and cheaper. As it gets cheaper, more people will use it. More people use it means Kansas uses it, right? So you should be excited. This is going to be a great wave that will not be isolated to the coasts. It's going to go all around the world. And the more that you build a key part of that supply chain, the more that other people will come here and take that key part of that supply chain. So yeah, thanks for your time.
Yeah. All right, thank you, Aaron. All right, so yes,
Can I say
Tanya,
one thing?
PSA.
Okay, you asked me up here, so
Yes.
now I'm going to interrupt.
It's your
So
show.
we just heard Jensen over and over and over and over. And so I just wanted to pay homage here to NetApp and to some of the talent we have in Wichita and in Kansas. So NetApp is here in Wichita because they bought and acquired LSI Logic. Anybody remember LSI Logic? Okay, LSI Logic, some of my co-workers that I used to work with, I worked at LSI and NetApp. LSI Logic was what used to be NCR. That's what started here many, many decades ago of talented engineers in Wichita. National Cash Register is our first computer. LSI Logic and then NetApp bought them. So LSI was a semiconductor company. They moved up the stack and started making customized storage, and then OEM'd it to IBM, Dell, Oracle, SGI, all of that. NetApp bought them. So why did I tell you all of that? So where did Jensen work? What was his last job before he started NVIDIA? LSI Logic. Yeah. He worked in Milpitas in the corporate office, but he has been to Wichita many, many times, has worked with many of our engineers and the talent here in Wichita. And outside in the lobby, there is a large patent wall out there, and it says NetApp patents on it. But really, those are the patents that NetApp acquired from LSI Logic, but they're only the patents from LSI Logic that are Wichita created. Okay, so every name out there and every patent out there is Wichita engineers that built part of the digital network. So I just had to interrupt because that's a really good little tidbit.
I'm glad you did. Thank you. Glad you did. I told you this venue was going to be inspiring. Wow. All right. Well, again, so we were out in the street. You were subterranean. We came into the building. Ivo brought our heart. We got a lot of neat transactions and processing going on now. Let's talk about the building, the mission, and how that begins to advance transformation in America. Connected Nation Internet Exchange Points, LLC, CNIXP for short, is a 50-50 joint venture between our nonprofit Connected Nation and carrier hotel pioneer Hunter Newby through one of his corporations, Allied Colo, LLC. CNIXP's mission is to ensure that cities, towns, and rural areas across America can enjoy the benefits of low latency, lower cost, increased resiliency, and by creating carrier-neutral meet points where internet traffic can be exchanged. CNIXP has established a goal to double the number of IXPs in the U.S. by creating 125 new facilities across 44 states, including Kansas. Brent Legg is an 18-year veteran and an EVP of Connected Nation and is the driving force and leads this JV on behalf of our two organizations. Brent is going to tell you more about the facility that we're building here at WSU and how it will serve as the archetype for many others as we set out to transform interconnection here in America. Ladies and gentlemen, join me in welcoming Brent Legg to the podium.
Hello, everyone. It's so good to see so many familiar faces in the room who have driven in from far off places. I'm just curious, for those of you in the room who are not from Kansas, raise your hand. All right. So I'm going to start with a conversation around what we're actually doing here, right? We're building interconnection. We're building interconnection between people. We're building interconnection for real reasons, not for technology's sake, but to impact humanity. So one of the reasons I asked you that question was that's a demonstration of what this project is already starting to do, and we haven't even really begun construction over there yet, right? We're bringing together people from all parts of the country to come together, to connect with one another, to do something meaningful here that will drive economic development for the next 100 years in this community, based on the foundation of what Wichita State University and people like Tanya Witherspoon have been doing here for many years, right? This is the next level. So thank you to those of you who have come in from out of town. Thank you to those who are actually from here, who are so invested in your community that you feel like you've got to be part of this revolution. We couldn't be doing this without you. And so for the mayor's leadership, all the way down the stack, we've had tremendous local support to get this project off the ground, and we're building the model for what we want to do all across the country. So I mentioned last night at our dinner, this is going to be the alpha site that we replicate in markets all across the country. And so we'll always be pointing back to Wichita. So let's dive into specifically what we're doing here. So you can walk away with a good understanding of, okay, practically speaking, what's going to be happening here over the next 8 to 10 months. So let me start out first with just a high level, macro level understanding of what internet exchange points are. And it's really my privilege as the lead on our IXP development joint venture with Hunter to be able to travel around the country and talk about this and talk about why these facilities are fundamental to the next evolution of the AI ecosystem, to create the AI ecosystem as a fundamental part of that ecosystem. And so what we're doing here is going to be a model elsewhere. So internet exchange points simply are internet hubs. They allow local networks of all types, from internet service providers to transport providers to tier 1 carriers to mobile networks and education networks, and cloud and content providers and AI intelligence systems to interconnect and exchange data traffic locally. So Amazon, Microsoft, Google, Netflix, etc. This is called peering. That's an elementary term to some of you in the room. It may be a brand new term to others, but it's going to be something that you're going to become more familiar with. So the more internet exchange points there are, the better the internet will work. So the closer you are to an internet exchange point, the better your internet performance will be. This happens by reducing latency. That was a big subject of my friend Ivo's presentation a few minutes ago. Reducing latency, improving internet performance. So right now, the state of Kansas, the city of Wichita, is really wholly dependent upon internet traffic exchange in Kansas City, Missouri, in a building Hunter used to own, actually, at 1102 Grand Boulevard. Used to be managed by my friend Greg Elliott back here in the back. Or a building at 910 West 15th Street in Denver, right? So Wichita, from an internet perspective, was hanging off of those two cities primarily. And we're changing that. We're bringing the internet ecosystem that exists in those cities down to cities like Wichita. So there are 57 metros across the US, like Denver and Kansas City, where IXPs exist today. But there are 14 states, like Kansas, that has no IXP at all. And so we have set out on a goal, on a mission, to solve that problem. And as Tom said, to build 125 of these facilities in 44 states across the US. So I've already sort of alluded to this talking point, but when a city like Wichita is hanging off of a city like Kansas City or Denver, you're backhauling that data traffic. You're tromboning it. Think of it as a trombone, literally. You're sending the data off far away to be exchanged and get a response back. So the further that trombone extension happens, the more latency that's introduced to every connection. So, when you go back to Ivo's presentation, you think about the applications that are going to demand super low latency in the future, well now, and more so even in the future. That physical distance, the physics of light, the physics of exchanging data traffic far off, we have to shorten that distance and bring that here, and that's what we're doing. So future internet performance is at risk if we don't build more of these facilities. So think of autonomous transportation systems and drones and AI and video streaming, two-way video, virtual reality, augmented reality. All of these things are going to increasingly become latency sensitive. And we can't materially reduce latency without an IXP. So there are multiple benefits, ultimately. Latency reduction, cost reduction, that was alluded to by a previous speaker, where we're creating a marketplace for competition. I think James talked about how bringing interconnection into a venue that was more neutral and allowed for multiple networks to interconnect with one another and compete with one another, that brings down wholesale costs. And it can bring that down by orders of magnitude, which then makes it possible for more people to buy more bandwidth. And then we're also creating a place where networks are actually converging and creating new routes for data traffic to be diversely routed from here, right? You're creating a place where networks build to and from. And so the Internet Exchange Point here at WSU will literally become the epicenter for network builds. It will be the address that networks build to and from in this region from now on, for the next 100 years. And that's extremely exciting that that's going to be right here in WSU's own backyard. So when we think of core infrastructure, core interconnection infrastructure, James, that's one of your manholes in my slide. Manholes, duct banks, neutral co-location, an IX switch fabric. Ivo, thank you for being our partner. It's so exciting to see Wichita pop up on that map of Ivo's global set of IXPs. Meet Me Room and Cross Connect, that's what Hunter has done throughout his career. Bringing cloud and content peering into the Wichita marketplace for the first time, and being able to significantly reduce wholesale IP transit costs here. So a lot of people have referred to the stack, or the what really is the OSI model here. You know, from the physical layer all the way up to the application layer. We like to say there's actually 8 layers to the OSI model, and layer 0 is the real estate. It's the things that we do and that James does, right? The IXP facilities, the conduit, the manholes, the handholes, that's the foundation to make everything above it. When you've heard from Aaron and Brian and Ivo, all of this has to exist in the physical real estate, and that's what we're going to build here. So our alpha site here at WSU is thanks to a $5 million grant from the state of Kansas, and I would be remiss if I did not call out Jade Pyros de Carvalho, the former state broadband director here in Kansas, who, if she had not gone out on a limb and had been a leader in this issue, on this issue, this whole project would not be happening. So I want to thank you, Jade. Thank you for the vision, for believing in us, that we're going to do this, and we're going to make a big difference in your home state of Kansas. We can't thank you enough. This facility is going to be built on 1.3 acres here on campus, donated by WSU and the Kansas Board of Regents, a 40-year ground lease, $1 a year. Think about that. So for 40 bucks, we're going to be able to deliver this facility and make this the epicenter for connectivity for the Wichita region and beyond. As you know, and many of you have seen, this campus is home to some amazing companies. And Wichita State has done an amazing job of building those relationships, that interconnection with industry, right? To attract major companies to campus, and Tanya's to credit for a lot of that. We're going to be building a 3-module, 2,000 square foot roughly facility, starting out as 25 cabinets, and Mike's presentation earlier talked about the modularity of that building. So we'll build the initial 3 modules, and then we'll be able to expand in 25 cabinet increments over time. And we can fit enough modules on that property over there to get to about 400 cabinets total, we think. It's going to start out at 350 kW in +1 power and cooling. This is a network interconnection facility. It's not meant to be a data center. And we've talked about some of the reasons why. Data center demands, power demands, cooling demands are different than the interconnection infrastructure than we're building here. But by building this here, we're creating an environment where the entire ecosystem, all of the compute power that will result to be located here, will hive around this facility. And this will become the geographic epicenter for AI in the central part of the US. That's extremely exciting. So we broke ground in May. We're going to be operational by late spring of next year. IM Data Centers, as we said, is our general contractor and our building manufacturer. So this is a view, if you see the little triangle there on the top of the screen, right across from X Stadium on the north side. The Kansas Free State Network is actually a state long-haul fiber conduit system that Jade's also to credit for. That's going to be built from western Kansas, from Pratt, through our building here in Wichita, all the way over to Pittsburgh State University, up to 1102 Grand Boulevard in Kansas City, Missouri, and down to Emporia. So that red line there, the conduit's actually going to be on both sides of the street. So that's pretty exciting. This is what it looks like from the opposite side. This is the parcel where you can see where we're starting sort of toward the right side of the parcel, and we're going to build further modules to the left. This is what the building, roughly will look like. Not going to spend a lot of time walking you through this diagram, but essentially everything that all the previous speakers had talked about leading up to my presentation is reflected somewhere on this diagram and where those things physically exist. So, James's manholes, right? All the way up to the building that Mike is building and the IX switch that Ivo will operate. This is what where the meet me area in the building, where physical cross-connect cables are run between networks. See all the carriers that are labeled on this diagram. We want to showcase who is in the building because that actually attracts more networks to come into the building. So the more networks are in a place, the more networks want to be in a place. And the good thing is they typically never leave. So once they're here, and that's exciting. So we had our groundbreaking ceremony back in May. This is Mayor Wu speaking. We had a good event, and we're super excited to get started. This is where we want to go. So all of the green dots that you see there on the map are other higher ed institutions that have already committed land to us in the same way that Wichita State has. So just south of here at OSU in Stillwater, my friend Tim Riley's here in the room somewhere, who serves on the school board in Stillwater, Oklahoma. We're going to hopefully do this at OSU as well. Again, getting back to this is the model in Wichita for the rest of the country. So thank you for listening. I hope this gave you a better sense of what's coming, what we're doing here, and thank you for your partnership.
All right, thank you, Brent. All right, this is the last presentation before questions. So come up with something snappy and smart, impress your friends and colleagues. How do I say enough about this next presenter? In some regards, this all been the warm-up acts for the headliner. Our next presenter is not only a partner with Connected Nation Internet Exchange Points, but he's also someone who's understood for years and had the vision for what taking IXPs and the secret that has long been held at these metropolitan areas, bringing them to these cities that have been left behind. That's how we had our kindred spirit, quite literally. The mission alignment is palpable. He's an American entrepreneur, investor, conservationist, and the owner of Newbie Ventures. His primary field of interest has been network infrastructure. As a co-founder, chief strategy officer, and director of Telex, he pioneered the carrier-neutral Meet Me Room concept and the development of carrier hotels and data centers in the U.S., leading to massive value creation and economic development throughout the country. Mr. Newbie is a recognized authority in the network neutral interconnection and data center industry. He has served on multiple company boards as a published author, public speaker, and has been quoted in several publications, including the Wall Street Journal, the New York Times, and USA Today. He's also the recipient of numerous awards, including being named to the Global Telecom Business 40 Under 40. And I've heard him once introduced as someone who has the best hair in tech. Ladies and gentlemen, Mr. Hunter Newbie.
Thank you, Tom. You had to throw that in there. Wow, what an honor and a privilege and a joy, and I'm humbled to be here with you all. Where to begin? Thank you, Tom. Thank you, Brent, Connected Nation, all the Connected Nation folks that are here today. Thanks to Tanya Witherspoon for helping us, and Jade for putting this together, all my friends and sponsors, everybody that's contributed here to put this together. I hope you all like the manner in which it was presented to you today. Thank you. I think in terms of the OSI model, and I'm really glad the way everybody put their slides together, I didn't really exactly look at every slide, but I just kind of said this is sort of how I'd like to see it go, and it went to my satisfaction perfectly. So I think of everything from dirt up, and most people don't know that the internet and the cloud and AI is mostly underground. They think it's in the clouds. A lot of people visually see poles and fiber and splice cases and whatnot hanging off of that. Today, you got a really good education on those network elements. I know some folks in the room are in that business and some other people aren't. We're all tied to technology. We're bound to it in our daily lives with the phones that we have and all the jobs and the work that we do. We rely on this network infrastructure every second of the day, practically. And it's the folks like everybody that you heard from today and more people in the room, and really, truthfully, everyone. We're all part of that. And for me, knowing what a carrier hotel was and discovering this whole thing back in the late 90s and setting out to buy all the carrier hotels, sort of play Monopoly and buy them all. I got a bunch of them in a few different deals, including 1102. But, you know, that's sort of the past now. There's still a path to acquire some other ones in different cities and whatnot. But I did have a kindred spirit and a desire, a strong drive to figure out how to take the neutral physical air interconnection business and physically distribute it across the United States into the cities where it wasn't. And we're doing that now. And to me, you know, doing a job right, it's how long is it supposed to take to do something right? As long as it takes. So we're here to do it right. Right, Mike? We built a lot of stuff together. So I just got to say thank you all again for being here. This is just the beginning. We're all available to answer questions. We're going to do a Q&A here, you know, with all the speakers so that y'all can ask anybody the questions. This is being recorded, which is great because a lot of folks couldn't make it. And we want them to be able to enjoy the benefit of hearing all this and listen to the Q&A. So that'll be available for everybody, and there'll be sound bites and snippets, and I'm sure Jess is going to put it all out there on social media. I really do want to say thanks to everyone, Ivo, you know, James, Brian, Austin, Alan, Mike. You guys are great for coming here and doing this and supporting what we're all trying to achieve here. They are truly experts in their fields, in their disciplines, in their lanes. You know, we walked around the campus today. Tanya did an amazing job once again of giving us a tour. I've seen it, and I go back and I tell everybody, this is amazing. You know, you're not going to believe it. And they came, and I got to step back and watch as she was giving the tour, the reactions, you know, particularly from Ivo, who's traveled the whole world and built internet exchanges in Dubai and Mumbai and every other place. And the amazement of, you know, seeing Airbus here and everything. The reason why this is really accelerating now, which is really serendipitous, is I've had my lane and Connected Nations had their lane, and Ivo's had his, and, you know, my new friend, James, who is the only person I've ever seen build manholes like that anywhere in the world. We're all converging on this, and it's all coming together at the same time with AI. And that's really why Brian and Aaron, got to thank Aaron for being here too. If it wasn't for real-time inference AI and the requirement for low latency, we wouldn't look like the geniuses. Everybody thought we were nuts. Matter of fact, when I told GI Partners, who I sold Telex to back in, whatever, 2006, they asked me what carrier hotel I'd want to buy next, and I said 11 to 2 grand in Kansas City, and they laughed at me. They were like, that's a flyover city. And I said, you guys don't know how the internet works, do you? You think he gets on the plane with you and flies back to Menlo Park? Goes through Kansas City. And been there, done that now, right? And Greg's here, and we work together there. That's a no-brainer. Everybody said, oh, 1102, of course, like, you know, of course. I mean, that building has 300 networks in it. So I said, I'm going to Wichita, and they're like, what, are you crazy? So they're doing it again, and we're going to prove it again. And AI is the wind in our sails, in our backs, you know, the tailwind, because the real-time inference applications, okay, we're not talking about training, we're not talking about, you know, batch, we're talking about real-time. I'll give you one that I'm familiar with. Major bank in the U.S. Is buying B200s, now B300s. As fast as they can, deploying them for fraud detection. They're detecting fraud at the keystroke on the phone as it's occurring. Before the fraud transaction is completed, they've seen it and stopped it. In order to do that, they need sub 3 millisecond RTD, round trip delay. 1 millisecond is 50 optical miles. 50 optical miles is not route as the crow flies. That's with, you know, the slack coils that James was showing you and whatnot. It adds, you know, distance in a run. So let's just say a little bit of a discount. 3 milliseconds is 150 optical miles, a little bit less, but still 75 in, 75 out. That means that you need to have from a device, okay, a switch, a router, and a GPU to capture the phone scrape and then send the data back to process and come back and say, is this fraud or not? So this guy is a global network design guy for one of these big banks, who's a customer of mine in another deal that I'm in. He was horrified to learn that there isn't a neutral real estate, okay, internet exchange point, with a neutral internet exchange switch in every single city in this country. Horrified. Like, to the point where he was like, who didn't do their job? And I'm like, that's a lot of capital, and that's a lot of time, and we've been waiting for you all to show up with your money to pay us. So since we're landlords, right, IXP, we have to get out there to all the dots on the map that Brent had shown you, and more, but those are the primary ones, the big ones, the diligence that we've done for all the cities, the population density at a certain level with no internet exchange, and then more than 100 miles to the next internet exchange, et cetera. But the customers are banks, insurance companies, healthcare. They all need this low latency for real-time inference. That really didn't even exist. It wasn't even part of our conversation until this year. But yet we started our business together several years ago. It's just amazing how this has all really come together. So Tom made a couple of statements earlier alluding to things that I would talk about. So one of them is the delineation between what is an internet exchange point and an internet exchange IX, so IXP, IX. This is the way that we define it. There's some other ways that other people use these terminology, but I'm just for the record going to say an internet exchange point is a building that's purpose-built for housing network equipment. And an internet exchange is a switch, and this is DKIX here, they're the world's largest, they use Nokia. So an IXP is defined as such if an IX is in the room. And I don't refer to these facilities that we build as data centers because I don't particularly like that term. It's an overused term. It's used to describe everything to the point where it has no definition. So single tenant, hyperscale, cloud, multi-tenant, enterprise, everything's a data center, blah, blah, blah. No. We build interconnection facilities, okay? So that's where the conduits come in and the fiber, and it's all the patch panels, multi-tenant, physical layer, you know, network to network, direct interconnection. That is its own very specific thing, its own purpose. That's what I do. That's what I've done since the late 90s in New York City, and I've done it over and over and over again in a lot of major cities in the US. That is not a data center. But what's called a carrier hotel, the term, is that there's no beds. Carriers don't sleep there. But we say carrier hotel, a lot of people don't know what we're saying. They think we're in the hotel business. And then there's a room in that building where all the networks that are in that building in different rooms basically extend their fiber into for the purposes of interconnecting to each other. And that room is called the Meet Me Room. That is a term that I'm, a pioneer of, utilizing. I won't say I invented it, but I've been one of the probably biggest promoters of that term. That's also not a term that we use because we come out here to Kansas or certain places say we're in the Meet Me Room business. They think we're in the dating business. Yeah. So hotels and meet me rooms is not what we do. So Internet Exchange Point, yeah, I know. Internet Exchange Point is a very specific built building. You've seen all that's today. This infrastructure is very precise. The inventory management system that James has created for manholes is second to none. That will be here, okay? That's part of what we do. And then second to last point is on this monthly recurring cross-connect fee business. So my original telex business model in New York at 60 Hudson Street was born out of my great disdain for local loops, which is a circuit between two networks provided by a third party. And because I was what's called a 214 or a common carrier, buying and selling voice minutes, by the way, I traded wholesale voice, swapped minutes and brokered deals around the whole world, India, Brazil, Mexico, whatever. I'd have to wait for months and even years for a circuit to be delivered in the same building between two floors. And I said, this is nuts, and I can't scale my business. So my buying power, I went to the carriers that I was buying minutes from, and I said, I will give you $1 million a month contract, but you must build into my room and put your equipment, your extended demarcation point in my room. And I'll manage that, but that's the only way I'll buy from you. And then I just kept doing that over and over again until I had enough carriers in the room where I got out of the minutes business entirely. And I just focused on having them connect to each other. And that was the first time that had ever happened. Matter of fact, I was told that it wasn't allowed. Did I ask permission and all this other stuff? I'm like, no, it's just, practical. But because I charge rent, okay, monthly recurring for the space and power and access, another word that was used many times today, I did not charge monthly for that interconnection between those two networks. I got rid of local loops. I didn't want to pay for that. I didn't want to wait. I didn't like the uncertainty, the unpredictability, the lack of transparency. So if the networks were in my room and I could inventory all of their infrastructure, I knew who was there, how many ports they had, what was in use, what was available, and I could promote them to each other, and they were very happy to be there. And I just charged them rent, and they loved me because I threw great parties, and we had awesome food, and we're still doing that. And I did charge monthly for that. That's changed, unfortunately, because of the nature of the way investments work. Investors bought a lot of the things that I built and exited to them, and then they looked at my customers as hostages. That's a kind of a strong word, but maybe sort of like network prison. I actually wrote about this in 2002, believe it or not. So they decided to impose monthly recurring fees for those interconnections, and those networks couldn't leave. They're stuck because they had hundreds, even thousands of connections to other networks in that same room. So unfortunately, I've built up a couple of companies and sold them, and then people that buy them want to monetize and get a return. And it's sitting ducks, easy to impose this. So I don't do that. I've never done that. I'm not a part of that. I still don't do that. And Connected Nation IXP doesn't do that. You pay us for access and space and rent and your own fiber cable to your own panel, but the individual connections between the two customers, there's only a non-recurring, not a monthly recurring. And that's something that I believe in very strongly and passionately, and everybody in the industry in the world knows that, so we're not, telling anybody a secret, but James also believes in that too, and that's why he created the Meet Me Street, because he was sort of put under the same imposition in Boston, and that's why I embrace what he does, we all do. There's no fear. I'm not afraid that the connections are going to happen in the street and not in my building, and I'm going to lose revenue. I'm not charging for that anyway. So if you want to ribbon splice in the street, go right ahead. If you want to terminate to a panel and interconnect everybody on single pair basis, go right ahead. So there's benefits to both. So those were the two primary things I think you mentioned, IX, IXP, and the monthly recurring cross-connect fees. Last thing I'll say, and then we'll get into the panel for the speakers, the Q&A, is about AI itself, and about Brian and his deployment of the B200s at Data Verge in New York, where I sit on the board. we are providing a physical interconnection presence, as Brent said, which will be this epicenter of interconnection, very similar to 1102 Grand in Kansas City or any other carrier hotel, except this is greenfield. We're starting from scratch, and we get to do it right, so the manholes aren't going to get all messed up, and everything's not going to get all jacked up, and we could build modularly, which is really important today because the power requirements for things they vary. But I've said, you know, we don't build data centers, and I swear this whole thing off, and then along comes AI, and it changed my everything because of the low latency requirements. So we'll see how it goes between now and April. We didn't design and build this facility to house GPUs. They're very power hungry. They generate a lot of heat, make an awful lot of noise. It's not the same as optical transport or electrical, you know, Ethernet switching, which is our, you know, primary bread and butter. But we will host a moonshot B200 to prove a point. And that's what I'm about to explain to y'all. So in New York, the premise for what the deployment was going to be in the first place with Moonshot Energy was to save them the trouble of spending a lot of money and building their own thing. Just stand up these GPUs in a facility that already exists. Hydra Host sits on top and aggregates the enterprise contracts. They're providing basically the bare metal service, and the revenue just starts flowing, right? It's like Airbnb for, you know, GPUs. So what hasn't been done yet, but we're going to do, because training model has been using generic GPU hourly rate leasing for several years now, I guess. The age of real-time inference is upon us. So now it is all about latency and RTD, round-trip delay, specific routes. So if you want to rent GPUs, generally speaking, you could just go do that, and it doesn't really matter where they are in the world. But if you want to rent GPUs in a specific city, now we're going to have like the option to do a drop down and say, I want them in New York, but we're going to take it further. We're going to say not just in New York. In New York, these GPUs are connected to DKICs, and the RTD, the round trip delay millisecond to all of the ASs that are on DKICs is this. Nobody's ever done that before. The visibility to what the actual speed, the delay, to go from this GPU to that AS. That's what the banks want to build on top of. And, well, since we're going to do that in New York, the next place we're going to do that's right here in Wichita. So that's pretty cool. So going from not having a facility at all to having all of this brought here really, yeah, puts you on the map. So, again, thank you all. I'm honored and appreciate it. So I'm going to ask the speakers to come up and just take seats. And I'll field questions. I'm not exactly sure how you want to do this with the mics, Jess, but maybe there'll be like one floating mic and...
We'll have a floating mic on each side.
Yeah, okay, yeah, floating mic each side, great,
And
perfect.
we'll have mics for the audience.
There is one?
Yeah, I'm getting you.
Okay, great. So how are we on time? I just want to make sure.
It's, we have about
15? Okay.
for the panel.
Terrific. Yeah, so not a typical panel because you've already heard from everybody. So this is a Q&A panel. Obviously, this is all for you guys. So everybody heard what was presented today. You have the brain trust here. So does anyone have a question about any aspect of this at all? Yeah, go ahead. Scott.
This is for James. So accountable infrastructure. You've been in the trenches for the longest time, and I heard you explain it very well, but you explained it from your side of the table. Give an explanation to the crowd, because I'm sure some people in here understood you completely, and I'm sure there's a layer of the group that didn't. Explain how this levels the playing field if a new ISP wants to come into town and they pay the same fixed cost as a billion-dollar company to get fiber infrastructure in the ground, and before they leave the manhole, they take a picture and they're held accountable to make sure that all the fibers are in the right place, stacked neatly, not interfering with anybody else's fiber. how much of a difference, because you've done it in Boston, and you've come from a smaller player to become a level player with some billion-dollar companies. Explain how that made a difference and why.
Well, thank you so much, Scott. That's a great question. So Boston is a very interesting city. If you are, say you're a new fiber provider coming to Boston, there's a huge get in the door fee. So the way it's built is that the existing, what we call CLECs, or the competitive carriers, those guys always complain anytime their access is being delayed by the incumbents, like the power companies or Verizons of the world. And the reality, both in New York and Boston for that matter, it's actually easier for you to work with a dysfunctional, bureaucratic, really large regulated utility. You'll never get anything done, but you're still going somewhere, than these competing carriers that are in Boston or many places. Because what happens with these competing carriers is that they cry when they don't get what they want, but they're not regulated like the incumbent utilities are. So when it's them owning infrastructure, they get emotional. They don't want any competition. They will use every trick under the sun to make sure you never get in. So what happens in Boston is the only way people used to get in is you either buy out an existing fiber provider that held those assets, or there's some weird stuff going on. And there's a lot of weird stuff going on in Northeast, right? So we're like, this is ridiculous. And down to the physicals and the technicals, right? A lot of times that these carriers also do, and Hunter has his own share of stories that are just hilarious, but unfortunately true, is they'll do, if these guys are some of the smartest guys out there, they just use it in a very unique way, right? They will do everything under the sun to make sure that if they are forced to let you in, they booby trap the manhole and the infrastructure to make sure that you have the horrible time running your cable. That as long as their purview is, if I get to delay your project by 6 months, 8 months, hey, keep selling, right? So that's been the norm of how things generally work in a lot of these cities. And I mean, even on the policy standpoint, we hear a lot of complaints and things, even on things like aerial pole attachments, like the make-ready process, things like that. Those things continue to come up as a matter of policy. Well, when we saw all of this happening in Boston, we said, there is really no excuse to all of this. And if we develop a system and design it and maintain it, make it maintainable, and the goal, if I were to use one word to summarize the mission of what we do, is access. Make sure everybody has access when you build it, and make sure they have it forever. And that is that type of model is not just the physical, technically, it starts from the business, from the regulations, working with the cities, our local authority partners, and all the way down to customers. Just make everybody's life easier, not miserable.
Thanks, James. Imagine like roads, you try to get off the road to go to your house and its driveway, but there's a wall in front of your driveway. Or imagine that your roads, they don't get paved and there's potholes. That's the manholes that he's talking about, and I've seen plenty of them too. We're not going to let that happen here. Question. Mary Beth.
Specific to smaller up-and-comers in the region, a startup that's building their business model around AI, a startup that's trying to dive into areas where they need more than their 1 or 2 persons worth of computing power. What difference is this going to make for them, and how will they access this now, world-class hub as a sort of an outsized user compared to enterprise customers?
That's a great question. Since it wasn't really directed at anybody, I'll just sort of preface it and then maybe hand it off. Where I've done this before, where there was a, heavily incumbent controlled sort of duopoly situation, the prices were very high. This is Ivo's example. And there's like that apprehension, fear, and then, what James said is the booby traps. They don't want any change. There's a lot of businesses in these environments that pay like a really high amount for just internet transit. When a facility like this is created, it's an ecosystem and it's neutral, it's a marketplace. So what does neutral mean? It means that we're not a service provider. We're just a landlord, takes care of the infrastructure, and all the networks can buy and sell and connect with each other. So the pendulum swings the other way. So really high cost transit, it comes down to what wholesale is in like an 1102 grand or a major carrier hotel. It's on a DKIX switch fabric. It's peered off, which basically is a free exchange of traffic, or it's the whole cost of a wholesale meg, which today is about 5 cents. That enables small companies that don't have big budgets to come into the room and get a port. There's a lot of different ways to do this. So metro fiber, metro transport, network operators, they generate a tremendous amount more revenue that they never saw before because that new neutral hub exists. You don't have to leave anymore on the internet transit. You can just come locally, and the metro fiber business, the metro Ethernet business, it explodes. It goes from there wasn't any to hundreds of gigs to terabits. And the revenue offset from the ISP part that everyone's scared to like lose is made up for 100-fold by all the local fiber connections, fiber to the tower and everything, fiber from these buildings, businesses, the stuff that Stevens Fiber Group does, et cetera. So any small company can get a port on a DKIX switch with a small budget and be able to connect to every major network very economically, you know, and the performance is really what it comes down to. And again, this part of this conversation leading up to today was everything sort of in the past about the internet and peering and whatever. We're in the age of AI. AI is coming. It's coming to Wichita. It's coming everywhere. But there's some cities, unfortunately, that don't have this type of infrastructure, and these very low latency sensitive applications simply won't work. And businesses won't go there because they can't function. And businesses will go to places that have this infrastructure because they can. It's just that simple. But
let me add something to this. I introduced the AI IX in simple words. What you're asking is how they will benefit from it, how smaller companies, they can get access to what actually. And what we see started happening outside is we see more and more AI inference as a service providers, not GPU as a service only, but also those companies who will introduce the agents, the models they have been trained now in action. And organizations of different types and from different industry sectors will start using those agents. Their predictions for millions and billions of agents, they will be in action. I would say kind of a general agents or industry segment specific agents, agents for specific manufacturing processes, agents for specific visual demand on products, etc. And talking about the immersive internet that goes further and further. So what we will offer in this facility is the functionality of the so-called multi-agent routing, or AI as a service, multi-AI as a service routing. So what is the benefit of? The benefit is that the connectivity to all these agents happens on site, on the platform. So it's extremely efficient. It saves costs because it reduces complexity. It's extremely secure because there is nothing between the company that wants to use the agent or the multi-agent approach and the agent installations. So there is not a third party between. This makes it extremely secure. Now the access options there too. Either those companies will establish their small presence directly in the facility, or they can also access through their preferred internet service provider, managed service provider. So both options are there, depending on the size of the companies, depending on their preference, right? But it will happen on site. And I can tell you this started to happen. DKIX sees more and more customers now globally from different industries. So it's not about a wholesale business anymore. We have car manufacturers, we have financial institutions connected already to the platform, and we see more and more to happen there. A construction company connected to the platform directly. If you would have asked me 5 years back, do you think a construction company will connect directly to an internet exchange? I would have told you it's a nice dream. Dream this further, but this dream became reality. And why? Because we are in a new era of data controllability. And data controllability leads to digital asset creation, or the other way around. A company cannot create digital assets if the company doesn't control the data journey. So we help to increase the level of controllability of the data journey for security, performance, and simplicity reasons. That's the economic benefit, actually.
That help? Good answer. Okay. Yes, question, please.
Hi, Michael Barrett. I'm a lifelong Wichitan. This is really exciting. Thank you guys for working on this.
Thank you.
James, you mentioned regulatory capture. Brian, I think you mentioned some regulatory issues. Brent, this might be a question for you. What's the most significant barrier in the regulatory environment that you're still encountering?
In terms of the creation of facilities like this, or?
Yeah.
Brent. He lives this.
Gosh, there are many, right? So, you know, one of the biggest barriers that confronted this project was the capital to build the building, right? This is a greenfield build in a city that has never had anything like this before, right? So if it hadn't been for the support of the State Broadband Office, the State Department of Commerce, the Governor's Office, this project wouldn't have happened. We've encountered many, many hurdles along the way. You know, there were restrictive covenants on the land, right, that we had to work through. We actually had to get a bill passed in the Kansas legislature to even allow us to be able to build on this property over here. Thankfully, it passed both chambers unanimously. The governor signed it into law. But that was one of the reasons why it's taken us so long to get to this point. So these are not really regulatory things. It's really capital. It's you know, local planning and zoning and restrictive covenants and all of the sort of burdens or bureaucratic things that you have to work through to get a facility like this off the ground. James may have some commentary about what it's been like to do this in a big metro environment like Boston.
Sure. Yeah.
So,
Yeah. Thank you. So, from a regulatory perspective, the primary barrier that we witness in our experience has been just the telecom providers themselves. Before we even get to the regulatory issues, they're just so dysfunctional, so hating each other. They just can't work with each other. Like, they just had. I'm like, guys, at some point you gotta grow up and just accept. And that's the primary issue. The second issue is to expand on Brent's point. So Boston's unique. There's like like 3 cities, right? That's kind of Boston Metro in the core. There's Boston proper, Somerville, and then there's Cambridge. So Cambridge and Somerville are quite innovative cities in that out of all of those 3, Boston proper is quite difficult to work with because the city actually have had a history of policies where they were dealing with all these carriers hating each other before there was even internet, back in the days of community access television of 1970s and all of that. So Boston has a lot of antiquated regulatory policies, if you will. The city is actually fully aware. They are working their butts off, if you will, to try to change and modernize a lot of those rules. Somerville and Cambridge next door have much higher leg up in that they didn't have any rules, and then now they're seeing all this stuff being cleaned up. So they're like, oh, we have a rule book to follow now. So they are kind of like much more advanced that way. So in conclusion, I think in our experience, the municipal partners generally have been very good to work with overall. And I think that part of what we do as infrastructure owners is that this is a community development, right? So it isn't, we're not just here to pull fiber, just sell our network. We understand the impact that our infrastructure has, positive impact. So we are ready to give back to the community, including partnering with the city to do what we need to do to make sure there's infrastructure that everyone can benefit from. From that, generally, the reaction from cities have been tremendously positive overall.
Thank you. Jess.
Hey everyone, thank you for being here. This is incredibly exciting. My name's Nick Whitley. I'm the CEO of Moonbase Labs, and we're at the application layer from Brent's diagram earlier. We're currently building practical AI agentic workflows for our clients today. How can a software firm help with this movement? And do you have any tips for us at the very top of that layer?
Wow. I mean, there's a couple of ways. Brian, you want to? Aaron, yeah. The highest layer we got.
So what are you doing?
Freight brokerage, thank you, pretty much pull details from emails and generate quotes using AI at the current moment is an example.
And you just want a perspective of what would be the greatest moat for you to build?
Not necessarily, like, there's multiple software firms here in Wichita, and I think we're all excited about this. It's like, what can we do at the top layer to help move this forward? Yeah.
Yeah, like I mean, one is that you should like presuppose that there's not going to be much specialty in any given model. Models are going to be commodities. The second is that you should assume that the trajectory of infrastructure is to sovereignty. So enterprises, they already bias towards sovereignty because cloud's like hard for them to understand despite it being so big. So the enterprises generally are drawn to the idea of like owning CapEx and being able to depreciate it because they can take that and put it somewhere else, especially with the big beautiful bill. 100% is a lot to take in the first year, so they're already kind of naturally drawn to that. So I think that for any kind of endpoint software application, it's more of a managed services deployment than it is a like straight up SaaS product. And I had this, like, I don't know when I gave this talk, but someone asked me like, who's going to make the most money in AI? It's like there's a Peter Thiel rule. He's an investor in my company that you who you know makes money is like who has the attention. So obviously there are two really big ones, which is NVIDIA and OpenAI. So like they'll make money. So semiconductors make money. The second group would be data centers. They'll make a lot of money. The third, which people thought was a hot take, but I still stand by it, is actually like managed services companies. Because nobody really understands exactly what's happening, but they just see something happen. And in terms of LLMs, and so fundamentally, it's because it's essentially non-deterministic machine learning. Like that's what it is. So it's like beneath quantum, not quantum, but it's like probabilistic. So in that world where you're trying to adopt it as an enterprise, that sounds uncomfortable, probabilistic, because your whole idea of an enterprise is deterministic. Like you have a top-down function, you try to limit variability between different stacks of people and different stacks of operations. So that means that the way that they'll probably adopt AI is through like a COIA, which is like McKinsey, right? Well, McKinsey told me to do it, right? So that's the way I think AI is going to go out into the world, is that software platforms are really become managed services companies that become COIA for people to like top-down execute. Think of it as like, this is not Slack. This is like OG enterprise infrastructure back in like the 80s and 70s. Like that's actually how this stuff is being adopted, where the CEO, CTO is like, we're doing this, and then everyone does it. And so that's where if you're building an endpoint customer service, like kind of the way you treat it. Don't do like the sort of free trial sort of stuff. It's just, it probably won't go anywhere. You got to like do like a managed services sale, top down adoption sort of thing.
Here's an idea. Deterministic routing. So all the companies that are here, let's just say Innovation Campus, right? They're going to deploy AI, and anything that's related to agentic or real-time inference, they will want to run it on GPUs that are here. So there's a combination of things that are taking place where if your business is developing applications that are real-time or latency sensitive, then, become a Hydra customer. It'll sit on his GPU. It'll be sitting in a rack that's connected to his exchange that comes through his manhole design into Mike's building, which we run. No. And that's your ecosystem. And if it's just bulk generic, it doesn't really matter where it is, GPU as a service, then, you could just use the public internet and like whatever. But Wichita will be on the map. All the companies that are here for the stuff that they do that has latency requirements that are GPU related, they'll be visible. And think about this from the perspective of the companies that are just here on Innovation Campus. Go look up in PeeringDB, which is this big global resource that everyone contributes into, what companies that are here have their own AS number, autonomous system number. So if they don't, they need to get one. So contact Aaron, who's the registry of internet numbers, and get an AS and get a router, learn BGP, get a port, and you'll be visible on the fabric. And there are really big companies here. I just pick on Airbus all the time because I think they're cool. And I'd be like, well, whatever the heck they're doing, they're going to have an AS, they're going to have a port on the switch, and the whole world's going to be like, oh, that's where they are. It's like, I want to fly to Wichita, ICT. That's where you go and you land at this airport and go to this gate, and there it is. And that's how you get in and out. That's exactly what this is. So if anything that I just said made sense, for the lane that you're in, that's the orchestration of everything from 0 to 7, like right here in front of you.
Direct flight time.
Direct flight, yeah, lowest latency.
Yeah,
I wanna-
Hunter, we have one last question.
I'm
and
voting
then we
for
need to
that New
wrap
York
it.
JFK to ICT, please, somebody.
Last question, then we're going to wrap it.
Last question. Say your name and where you're from, please.
Brian Duffner, Connect Base.
Thank you.
So we've talked a lot about low latency with AI inferencing, and we're seeing a lot now with communities kind of revolting against these data centers that are going to hold these high-powered GPUs and everything else. What is the next step to get past that? Because if we have an internet exchange, that's great, but as you said, 75 optical miles, that's not that far away. How do we get past that with communities to say, put this here to get this experience?
That's a really great question, Brian, and that's exactly why I say I'm not in the data center business. Duh. I never liked data centers. I don't like servers in my meet-me rooms. They take up too much power and they generate too much heat and it impacts my margins, and I just don't like it. It's not, it doesn't appreciate the specificity of the physical layer and the beautiful stuff that happens here. But it does generate the need and the servers that, you know, CPU, cloud, could be sort of anywhere, but I got a funny story to tell you that I can't because I don't have time, but AWS Outpost was shipped here for one of the aviation companies, and they ordered a private cloud, and AWS showed up with the private cloud, and they said, where do you want us to put it? And they were like, what are you talking about? They said, it's 10 racks, 150 kilowatts. Where do you want us to put it? They're like, we don't understand what you mean. Aren't you going to just give us like a link and a password to log in? It's in the cloud, right? They're like, it's on the truck outside, and you got to put it somewhere. They're like, well, we don't have a place to put it. That's a data center application. So, of course, the guy that was stuck in the middle of that called me and said, hey, can we put our stuff in your building? I said, hell no, that does not go in here. So the interconnection facility, Internet Exchange, does create this data gravity interconnection hub, and data centers hive around these points. Carrier hotels generate dozens, if not hundreds, of data centers. They're different. It's, somebody made the reference to the brain and the heart. They're both part of the body, yeah? But is the brain the body? Is the heart the body? No. They're different, and they have different functions. The brain's up here, it's in the skull, that's kind of like the data center, and the heart is like the Carrier Hotel, and the veins are like the fiber. So I'm in the heart business. So you brought up a really great point, and I've talked to Tom and Brent about this for years. I'm going to give it to Mike. I don't want to talk about this because NIMBY was coming, not in my backyard for towers, not in my backyard for data centers. And everybody's all scared about the power's gone, oversubscription, which is true in many places. It's been oversubscribed. But you're smart. This is Kansas. You haven't had this problem that Loudoun and Prince William County in Virginia have had in other states. You can do it the right way and manage it appropriately. You don't give away the farm, you know, to whomever, because I don't know. I don't want to pick on any names, but some hyperscaler would come and say, we're going to build a gigawatt thing here. And if you're a state that's never had this problem, you're like, oh, let's do this big deal, right? But a lot of these states and the governors gave away big tax breaks, incentives and stuff to attract data centers because they thought it was going to make the internet faster locally. Those two things have nothing to do with each other. These big data centers that were built in states that sucked in all this power and water backhaul to an interchange point in many states away in many cases. So, Mike, you want to add something there?
Just that data centers fit hand in glove with internet exchange points. It's a different animal, clearly. And but I would say, you know, let's say if you had a forward-thinking university, you know, here in Wichita, if you know any, and they wanted a high-performance compute data center, you know, for their own needs and also to attract grant money, and then there could be another segment of that data center for vendor use, sort of traditional co-location, and it was focused on high-performance computing. It just seems like that's an accident waiting to happen here in Wichita, perhaps, is a high-performance compute data center with the right characteristics. Now, it's true that data centers do guzzle a tremendous amount of power. The art of the possible with data centers is if you need this much power to support, your IT load, the trick is to have the minimum amount of power to be able to support that IT load. Traditional data centers, that's called PUE, and traditional data centers, run at a factor typically of north of 1.5. We're getting PUEs down less than 1.15. So the only thing we can do as data center providers and, towards reducing carbon footprint and energy consumption is just make them uber efficient, which is a really core tenet of what we're doing. But yeah, I would say Wichita is ripe for a high performance compute data center.
Let's do it right.
I'll give one more addition there. So data center development in general, right, in America right now is obviously a hot topic. The way that you go about, right, obviously for all of us here today, being respectful, right, and ethical is, who you are. And I think the team that's been put together and just going forward, right, is how it's presented to the people in the community. The counties and what have you are all going to have a say, right? There's going to be naysayers. You're not going to be able to please everybody. But, we would do deals up in, the Dakotas, right, or areas where there is deficiencies, where those counties might not have school money or tax money, right, to help. And sometimes what we do is we would impose a self-inflicted tax, right, depending upon where that community or county is being deficit to help offset, right, that ask of what we're doing, which is taking land and power. And in addition to that, there are multiple ways, right, to offset the look or the facade or the noise, right, which obviously comes with a lot of this stuff. So there are multiple ways to offset the concern of power usage, but I think the biggest thing as well is employment, right? What is the community getting out of the data center? And that's knowledge and experience and the ability, right, to go in and see it, touch it, feel it, so.
Excellent point, Brian. And I think we're in the presence of someone who's an actual master at bringing businesses to a campus for workforce development. So maybe there's a structure there for attracting data centers if they hire people. I don't know, you could probably figure that out. And we can allocate the power to the people that actually hire people here and don't just give it away to companies that backhaul their data to some other city or state. Are we good? That's it. Okay, thank you. Please join us. We're having a reception. Oh, wait, oh, that's right. We're not done yet? Oh, all right. I'll just, housekeeping. There's a reception after this. We're not leaving yet. The mayor's going to speak. It's at the Digital Innovation Hub. Thank you again.
All right. Well, as Hunter said, I think it's been a great day. Let's give another round of applause for our speakers. The conversation doesn't end now. We're gonna shortly break over here, and just logistics as you head out of the conference room here. If you take a right, you can walk through the courtyard into the and by the pond or the pond lake.
No, it's a lake.
It's a lake. It's a beautiful lake. Some say it's the prettiest lake. And then into that building next is the where we'll have our reception. But before we do that, we want to bring up two very special guests to help close this out. And we put her at the end because if you've ever had to follow this mayor, it would be a tough act. This is a very one of the country's bright, energetic, and just spirited leaders. And Wichita, so we're jealous in my neck of the woods that we don't have somebody the caliber of Mayor Lily Wu. Mayor Lily Wu, who was elected mayor of Wichita, Kansas in November of 2023, following her time as an award-winning local TV journalist. Mayor Wu is a trailblazer. She is the first woman elected to a full term in the largest city in Kansas and the first Asian American mayor in the state of Kansas. As mayor, she has championed an inclusive vision for the entire city, focusing on ensuring public safety, strengthening the economy, restoring trust in City Hall, and building a unified community. Joining her is Commissioner Ryan Beatty, representing District 4 for Sedgwick County. Ryan played baseball at the University of Kansas and was named an All-American selection, named the 2004 Jayhawk Scholar Athlete of the Year, just two among the many honors he had earned while a college athlete. He went on to play professional baseball with the Tampa Bay Rays organization and later founded the Mattress Hub, one among many successful investments. Please join me in welcoming Mayor Lily Wu and Commissioner Beatty.
Thank you all very much, and I am just so excited and inspired. I know that today we are commemorating the day of 9/11, but when I came here, what I'm leaving with is excitement, hope, and truly just a pride that I have in this community. This is the air capital of the world, but we are Wichita, Kansas. And so welcome to all of you who are guests to our community. I hope you will return often. I am so honored to truly serve this community. As a first-generation immigrant, the innovation that's happening all across the United States, but right here in Wichita, is the reason why people still call this the Mecca for hope, for innovation. So thank you all for reminding me that. James, you come from Boston, there's another Mayor Wu there, but you're always welcome to come here to this Mayor Wu's hometown. I was taking down lots of notes, and among those notes, I was saying that there's some ABCs here. It's about foundation, and when you create a foundation, it is built on respect and responsibility. And this is what we're creating here in Wichita. It's respectful to the community that's already built around here. That's why it took just a little bit longer. But it's also built on responsibility because we want to make sure that people, A, have access. B, that we're gonna build it. So thank you, Hunter, for believing in Wichita. And C is really about this summit. It's about connection. That is what we are here to do, the ABCs. And so I just am so proud of this community for saying yes, for being a place for builders, for thinkers, and pioneers. We're proudly known as the air capital of the world, a title earned through decades of excellence in aviation manufacturing and engineering. And to me, air stands for something. It stands for aviation. It stands for innovation, and it stands for research. Now we can extend our leadership beyond the skies and into the digital frontier by embracing AI, smart manufacturing, and digital transformation. This is about preparing our region, not just for the next steps, but for the next leap. The cornerstone of that leap is infrastructure. I want to highlight an extremely transformative development for our region, the launch of the Wichita Internet Exchange Point, or IXP. This new IXP is a game changer. It gives Wichita something most cities our size don't have: a powerful, neutral, digital interconnection hub. That means faster, more reliable internet, reduced latency, and a cost-effective way to move massive amounts of data, exactly what AI development requires. But let's be clear, this isn't just about technology. This is about economic development. It's about positioning Wichita as a destination for AI companies, hyperscalers, large data centers, and startups. It's about supporting our aviation, healthcare, and manufacturing sectors with the digital tools they need to compete and win on a global stage. With this infrastructure in place, we can attract new investment, retain top talent, and grow the kinds of jobs that will define the next generation of Wichita, Kansas. We're not just preparing for the future, we are building it. And so I am so excited that Connected Nation, all of you, made the decision to come here to my alma mater of Wichita State University to see innovation and building what we together can build to make sure that everyone has access, is building that, and continues to be connected. Thank you so very much.
Well, thank you, Mayor Wu. I appreciate your insightful overview, and I'm the guy who gets to follow her at a lot of these things, so. She does a wonderful job, and she represents the city well, Mayor. Thank you so much. My name's Ryan Beatty. I'm the chairman of the Sedgwick County Commission, 20 cities in Sedgwick County, and we are excited about what's happening here in Wichita. It's a privilege, really, to join you today and help build on this momentum we're creating here in the city of Wichita. As the mayor outlined, our digital infrastructure is setting the stage. But as everything in this community kind of hums along, it hums along with the people and the community that propel us forward. It's about our people here and what we do here. I want to share just a couple thoughts as you guys are finishing up today. The first is really on talent and workforce development. We heard this a little bit on the panel. The mayor touched on it, but institutions like Wichita State and WSU Tech are key partners in leveraging IXP and what they will be able to do through training students in AI. But it's not just in AI, it's also in other fields like data science and cloud computing. And they're going to be using infrastructure that mirrors global hubs. What we're building here is an infrastructure that's going to propel a workforce and propel development long into the future here in Kansas. These educational powerhouses, Wichita State Tech, they help us to train a workforce and this next generation of technology and a local AI ecosystem that will retain talent and attract new professionals all across this region. Wichita will not just be a consumer of AI, Wichita is going to be a producer of AI innovation. And we intend to be a continued hub for innovation long into the future. Second thing, and this is something that in my job in representing people in this county is I've got to be able to tell the story of the community benefit. What's happening here and how does this benefit our community? And the benefits are profound. AI companies are drawn to communities with strong digital backbones. And Wichita can position itself as a significant and a neutral digital gateway for this entire region. Local entrepreneurs and small businesses will benefit from reduced connectivity costs, making them more competitive in digital markets. Mary Beth, we have an opportunity here with our small business community and our entrepreneurs, and we need to leverage it. This helps close that digital divide and ensures that AI's benefits reach residents, it reaches schools, and it reaches our public services. The last thought, it's our strategic geographic positioning that ties all of this together. And this is an asset that we will continue to leverage. Wichita sits at the center of this country's transportation and logistics network. And now it can become a center of digital traffic as well. The IXP strengthens our role as a strategic crossroads for both goods and data. By combining our historic strengths in aviation, manufacturing, and healthcare with AI capabilities, Wichita can lead in applied AI innovation. And the opportunities really are endless. Think about predictive maintenance in aviation. Think about precision healthcare. Think about smart manufacturing. That's what's on the horizon in this community because of these types of investments. Instead of merely adopting new technologies and strategies, Wichita will become a community that develops them and leads the nation in implementing them. We desire to become a roadmap for America on how to integrate AI to the benefit of its economy and our citizens, showing how we invested in the right kinds of infrastructure to make this happen right here in Wichita. I really believe, Mayor, that we can go from becoming just a smart city to become the smartest city that others want to imitate, the gold standard and the roadmap that others can follow across the country. I want to thank you guys for being here. It is so inspiring. I agree with the mayor, listening to these conversations and knowing what's coming. It really, truly is an inspiration. I hope we continue this conversation and hope we continue to build this together. Thank you for being here today.
All right, almost done. Last order of business. Again, I want to thank all of our partners for the summit, both for our presenters today, as well as our sponsors, and those partners that helped us promote the event. We are capturing this. We'll provide it later, short form and long format. Also, I believe the content slides will be available as well. Corrected slides as well. Also want to thank our gold sponsor, Moonshot, for making this summit possible. Of course, thank our platinum sponsor, Stevens Fiber for making our cocktail and networking hour possible, and of course Cisco for our silver sponsorship. Also, on that note, follow our team over to the Digital Transformation Hub. Again, out the door, to the right, past the lake, into the new building. Bring your tickets. There will be prizes. That's in the back of your lanyards. In addition, we'll be doing some, hey, if you listen to our podcasts, well, our podcaster is right here, and she is going to be roaming with a microphone and sticking it in your face and getting your best comments. But if you want a more sit-down, intentional conversation, she is always game for that as well. And on that note, let me call out special attention. Jessica, and where's Stephanie? Stephanie, she's already at the cocktail, so those two ladies, this wouldn't happen without them. Jessica Denson, Stephanie Slack. So for me and everyone at Connect Nation, thank you, and let's have the conversation continue. Have a great night.